Thanks for morning, everybody, and thanks for coming to the supply chain session. Obviously, few people in the audience, but hopefully it'll build up as we move forward and get into the topic. For those that don't know me, I'm Tim Lawrence. I'm Director of Digital Supply Chain at the Digital Catapult. I lead a program called the Digital Supply Chain Hub, which I'll pick up in a little bit more about, which is one of the Made Smarter Innovation Hub programs. Today we really want to talk about the theme of supply chain and supply chain innovation and how innovation is addressing today's supply chain challenges. And to be honest, supply chains are yet again in the news, really, aren't they? We've heard only recently in the last few weeks about the trade tariffs that are going to impact global trade again. Trump administration with his America First policies potentially impacting global supply chains. So again, supply chains really are in the crosshair, and innovation is needed more than ever to address the risks and optimize the opportunities and to support growth. And there's been a huge amount of activity across the materials and manufacturing streams of work around supply chains. And so today we're going to spend a little bit of time going through the sorts of those opportunities and the topics that really are, shining a light on what can be done around UK innovation in relation to supply chain. So I'm going to move, first of all, into the first theme. Just a little bit of an introduction to what we're doing in the Digital Supply Chain Hub, which I'll pick up in a little bit more on in a second. But in terms of the agenda for the first three sessions this morning, we're going to start off with an introduction to the supply chain innovation theme. We really want to pick up on what are the challenges that supply chain face today and take a different perspective on that from an industry view, from a logistics view, and then from an SME and technology perspective. Then we're going to move into a session, and we've sort of themed the day around sort of three key areas: supply chain resilience and the technology and innovation that we're doing to address the resilience challenges. And then we're going to move, and that starts at 9:20. We're then going to move into a session on sustainability and resource efficiency related to supply chains. And again, picking up on the sorts of innovations that we're addressing through that theme. And then we'll get to 10:55, and then we'll move back into the plenary session and the break. And then this afternoon, we pick up again at 1:30, where we'll be talking about an introduction to the climate challenge. We're then going to talk about new supply chains. So how is innovation addressing the new supply chain agenda? And then we're moving into a panel session really talking about what next for supply chains. So what's coming next in terms of the challenges that supply chains face, but also the innovations that need to be addressed to impact those challenges. So that sort of hopefully gives you a bit of an overview of what we're doing across the day. But first I really wanted to introduce what we're doing in Digital Catapult and in the Digital Supply Chain Hub, just to get an overview of the sorts of key things that we're addressing as part of the overall program that we're running. So Digital Catapult is all about accelerating the application of deep technology to realize a better future for the UK. And we're really looking at four key themes as part of that, and our missions really. One is to enable UK deep tech companies to scale. The second, and obviously important for this area, is improving UK industrial supply chain resilience. And then closely linked is the decarbonisation of industrial processes through deep tech innovation. And finally, the networks and the infrastructure needed to support digital technologies. And one of the key things then, as I mentioned earlier, is the Digital Supply Chain Hub programme, where our vision is really to transform UK manufacturing through digitally empowered supply chains that are more efficient, resilient and sustainable. And what we've been doing over the last 3 years is really thinking about what those supply chain challenges are overall, and we've themed them into 3 key areas, as we mentioned, and we'll go through today. But you can see the sub-challenges below those. And industry, and I'm sure Clive will resonate that, and others in the room, have really sort of highlighted those as the key areas that need to be addressed to tackle supply chains. What we've been doing in the hub is really developing around 30 to 40 digital technology solutions and innovations, working with the industry and tech innovators, and we'll talk about some of those as we go through the day. We've then been looking at test beds and how test beds can be used to deploy those solutions, and we've set up 4 test beds, one in hydrogen, one in automotive spares, one in food, and one in circular textiles. And those test beds are trying to develop a multi-tier supply chain that can be used, the data that can be used in those supply chains to really test some of these innovations and solutions that we're developing. Because one of the challenges tech innovators have is they really don't have an environment to be able to test their solutions and see how they work in live businesses. And then finally, we've been developing a platform which has now been launched in July last year, where industry can find out a lot about all the capabilities and technologies needed to adopt digital solutions in their businesses. We've got a stand outside, so you can go and find out more about what we're doing on the platform, and actually see the sorts of things that that's being offered and how we're helping organisations on the adoption journey. So what have we achieved so far? Well, in terms of the overall hub programme, we've invested about 11.5 million from Innovate UK, and we've had an investment from industry of around 15 million. We have around 280 businesses engaged across 18 different sectors in the programme. And importantly, in terms of some of the outputs that we're achieving through the digitisation of the programme, we've seen on average a 14% improvement in productivity through the technology solutions we've been developing, a 15% reduction in waste, and we'll pick up that in a bit more detail as well, and an 8% reduction in CO2. So hopefully you can see we're already making quite an impact in terms of the ability to transform UK supply chains through digital technologies. And on top of that, we've now got 700 organisations involved in our platform and individual sign-ups, and we see the sort of growth of interest and opportunities around digitisation of supply chains. That just gives you an example of a few of the organisations we've been involved in, whether that be large companies, tech SMEs, industry bodies, or academia through what we've been doing. And finally, if you're interested in joining our community, then please find us on the stand or connect to us through the QR code that you can see on the screen there. So I'm now going to ask my colleagues to introduce the theme, to come up on stage. So we've got Clive from Cranswick PLC, who's R&D Director. We've got Phil Rowe, who's President of Logistics UK. We've got Toby, who is Chairman of MBT. So if you can come up onto the stage, please. So Clive's going to give us a bit of an introduction to an industry perspective on what's happening in supply chains, particularly for Cranswick, and then we're going to move over to Phil, who's going to give us the logistics perspective, and then Tabu is going to pick up and give us a view from the technology and SME innovation angle as well. So Clive, over to you.
Thank you. Good morning, everybody, and welcome. I was going to say it's great to see everybody so early engaged and energised in our sort of presentation, but we have got a few, so we're pretty happy with that. I'm going to attempt to give you a very quick overview of industry challenges that we see in our food manufacturing supply chain and how we're looking sort of forward to use innovation, digitalisation and AI in our sort of supply chain, if you like. We're looking to be more sustainable, a bit of a buzzword, but we are. We're looking to reduce food waste. Food waste in the UK is really at an immoral stage, and we're all paying for it. So by getting a lot more connectivity and efficiency through our processes, that should deliver some massive gains sort of going forward. Where do I press? Oh, I've got it. So you may have heard of us, or you may not have heard of us, basically. But Cranswick PLC, we're primary processor of pork and poultry. You've probably heard of M&S, Sainsbury's, Tesco's, Asda, Aldi, all these people. We're a main sort of contributor of all their sort of products in our sector, if you like. We're a vertically integrated business, so literally sort of farm to fork. We've got 22, 23 and building well-invested food manufacturing sites across the UK, backed up with hundreds of farms in pork and sort of poultry. We've got 15,000 colleagues working across the business, and I think this year, end of year, we should probably see turnover reaching about 3 billion. So we've got quite an organisation going there. So I'll give you just an indication of the sort of pork supply chain, really, and some of the complexities that we see. So, in effect, we're dealing with, we're sort of, I'd say 85, 90% vertically integrated, so we own our own farms and agricultural division. The life cycle of producing a pig from artificial insemination through to sort of slaughter weight, if you like, is around 341 days. And we've got the largest outdoor pig herd in the world, basically. A lot of pig herds are all in controlled environments. Ours are a lot of outdoor reared, outdoor bred herds, which do give their own problems on biosecurity and disease, so we have to be very careful on that. We're producing about 75,000 pigs a week. And if you take that 341 days or 52 weeks growth period, we've got in order of about 3.6 million pigs on the ground anywhere in the UK at the minute. So that's coming at us at a fast rate of knots, really. And we're sort of taking a whole unit and then breaking it down into components with a very short shelf life, as opposed to something like the car industry, which bring thousands of units together with long shelf life, and then they create a unit, if you like. So it's quite complicated. We then sort of take the pigs, we break them down into sort of 6, 8 primals, 50 different cuts of meat, if you like, and then we busily, business to business, through our different enterprises through the UK, pork chops, bacon, sausage rolls, whatever you might see in the high street brands, if you like. But one of the big difficulties we've got, after that year of growth, we've probably got about 10 to 12 days of shelf life to get this through our system. And when we're doing all this, we're actually producing one pig about every 13 seconds through the process. So we've got a lot to go at. 28 days for sort of cooked or cured products. And then just to add insult to injury, we could have ups and downs in ordering patterns between 400% on a summer's day, or a cold, wet day, orders could drop. So we've got to put this massive, complex jigsaw puzzle together, really. And then to add insult to injury, if you like, we've got all our legal due diligence to put this whole supply chain together, which is essential in food safety. So we've got about 1,000 reported documents recorded for every pack that hits the shelves. And I won't go through that in too much detail, but traceability, animal feed, the way we rear stuff, slaughtering, FSA and veterinary controls, food safety controls, whether it be raw meat that we sell or ready-to-eat products. So, and it goes through the supply chain. So looking at all that, what we put together, how are we going to deliver better results, really? Well, we already have got a fantastic record. I think one of the guys was saying earlier, in the industry, it's renowned, our sort of track record. But Cranswick, we do continue to deliver excellent results in growth, diversity, sustainability and profitability operating. But we've got 40 million packs on the shelves every day right across the UK. And if you think each one of those packs has got 1,000 reports attached to that one pack, the data that we've got is unbelievable. So we operate many different systems, ERP systems, to carry out our day-to-day activities, but a lot of them are electronic. We've got a lot of manual, but what we haven't got is connectivity. So there's a lot of data in silos that we can improve with sort of connectivity, really. So driving the future of interoperability, manufacturing 4.0, 5 and 6 are coming. We know that we can deliver an extra 10 to 20% efficiency through the supply chain, and we can reduce that mountain of food waste. So that's where we're looking to take innovation and digitalisation forward in the business. So my responsibility is to try and get this culture change within the business and make sure that we're connected to, you know, the sort of entities that we've got on our government platforms, especially we're connected with DC. And I think that sort of covers me, Tim. So hand over to Phil.
Yeah, so thanks, Phil. Yep. Get the logistics for you.
Thank you very much. Good morning, everybody, and thanks for the invitation to come today. My name's Phil Rowe. I lead the Logistics UK. We represent the logistics industry. And you think, well, we're talking about supply chain resilience earlier on. We also talked about efficiency. And fundamentally, logistics underpins every sector of the economy. And sometimes it means that it's overlooked. But actually 8% of the UK workforce work in the logistics industry, and the growth and efficiency of our industry is fundamental to the economic challenge that we face. So I'm really going to focus on probably more macroeconomic issues rather than the micro issues that Clive was talking about in terms of the complexity of his business. I think we all know and we hear all the time that the UK faces a significant growth challenge. The economy has been very flat, really, for the last 16 years. And within the logistics sector, we've identified multiple ways in which innovation and the right investment can stimulate growth in the UK economy. If you look at the logistics performance of the UK, it's actually slipped down the world ranking from being third 14 years ago to now being 19th. If we could improve on some of those areas, we believe that the work we did with Oxford Economics identified up to an £8 billion growth opportunity for the UK economy within this decade. And there's a number of different areas where we need to focus, and digital innovation is a key part of the formula for how we stimulate growth and overcome some of those challenges. And you can see those actually on the slide there. And I'll talk in a moment about how I think the work on digital innovation can help overcome these, and what I've seen working with Tim and the team at Digital Catapult, and how that could be applied in practice. But some of the big areas for the UK economy are trade. Our trade performance has diminished markedly since Brexit. We have a much higher complexity. We also have many fewer, particular small and medium-sized businesses that are actually engaged in trade. And that's primarily because of complexity and cost. Our infrastructure, well, it's great to see there's going to be an infrastructure strategy, but actually focusing that on the things that will stimulate growth in the economy, lead to better performance, is a key opportunity. I'll talk a bit about decarbonisation, but that's the biggest challenge of our age, hugely complicated. So when we look at these challenges in the round and we say, well, actually, how do we move forward, and what is the role that we see for digital innovation in meeting these challenges? Well, I think there's four main ways that I've seen the innovation work that's going on within DC really can help to build and overcome these challenges. The first two together really are the ability for digital innovation to create insight by making things visible that aren't visible to people, particularly when they work across multiple sectors. Decarbonisation is actually a superb example of that. In order to decarbonise UK transport, we need to provide whatever power we're going to use to nearly 300,000 locations across the UK. But actually, the sectors that provide the power, the sectors that use the power, don't really talk to each other a great deal. And what we need to do is to find ways of bringing that information to bear in the design process as we go forward. And actually using digital technology, and there's a super case study that the guys ran on interoperability, which allows the translation of information across sectors, allowing for all that sector speak that every sector has, to be able to understand their requirements and understand one another. Where you have fragmented markets, and we have that in logistics to over 200,000 organisations, data management, getting to an aggregate position to make sure you make the right decisions is a difficult task. Again, digital technology has a great role to play within that area. There is an undoubted ability to boost efficiency through digitalisation. In my time when I was working at DHL, we had a global digital program for exactly that reason, because digitalising processes is a huge way of driving efficiency through the organisation, a way of tackling waste, as Clive was talking about a moment ago, but also a way of enabling collaboration. And collaboration is a super way of reducing waste, of reducing of aiding our decarbonisation challenge as well. And the project that we've been running, particularly looking at transportation, allows organisations to collaborate with each other in a very, very sophisticated way, which gives people choice and the ability to add value to their organisation. And then finally, and I think this probably leads quite well into our final speaker, digitalisation also creates the opportunity to create new businesses, to create businesses that can do things that businesses have never done in the past. So I'll leave you with this slide, my own view on how we drive innovation forward and collaboration, and I'll hand over to Toby.
Morning, everybody. My name's Toby Bridges. I chair a SME based up in Newcastle. We're a 117-year-old, what once would have been called an industrial distributor. Today, perhaps we call ourselves a supply chain manager. Our clients in the main, press the right button there. So yes, MBT Group, our clients in the main are manufacturing sites, and we will manage everything that they buy. Invariably not bill of materials, although we do quite a lot more these days. It's mainly the products that are managing the plants themselves, so whether that's a welding tip or a pair of shoes or a pen, we manage all of those. So usually invariably hundreds of suppliers, thousands of parts, tens of thousands of transactions a month. And that's essentially what MBT does, and I say that's what we've been doing for over 100 years now. As we've gone on a journey within the business probably in the last 5 years, we've really started to look at this. So once upon a time, we would say, yeah, we were a parts supplier. That's what we did. We did very well. Today, what we're looking at is how do we really look at and improve the world that we live in? One of the biggest concerns that we had actually as a family business, when we talked about it a lot, was there's a lot of overconsumption in the world, and for us, that's what's making the world burn. We're just making too much stuff. We're sending it to the wrong places. We're not using it, and we're throwing it away. And so that piece around overconsumption has become a real focal point in the business, and it was reflected, and you'll have all seen it in the news that the NHS had this £1 billion worth of PPE bought during the pandemic. And whilst that might be a really obvious one, that happens everywhere, and we were really conscious of it because we've been part of that problem for 100 and odd years. So just looking at that list of things that are on there, what we've really focused on hard is probably those top 2 or 3 pieces at the moment around how much you're buying, are you buying the right amount, those sort of things, and then getting into our carbon footprint. In the last year, we've reduced our scope 1 and 2 emissions by 60%, just because we started to focus on it, which then obviously brings natural benefit to our clients. But we really wanted to get into that top piece really around overconsumption and waste. And one of the challenges that we saw is that in the business that we do is that literally people don't know how much water they've got in their bathtub, so they don't know whether to turn the taps on or off, so they don't know whether there's too much coming in or how much is going out. So invariably you're just caught in a fog, you're caught in the steam of looking into a bath and not being able to see the water. And in my head, that's how we looked at it. So working on that principle, it's really essentially what meant our clients coming to us going, Toby, look, we haven't got enough, or we've got too much, and it was just constant all the time. And for 30 years of my career, that's what it was. Either people shouting us about having too much or not enough. So as we went through all the process and thought about all this, what we started to recognise is because we're doing so many transactions and there's so much going on, it's really very difficult for humans to manage it themselves, for people just to manage it themselves. So what we did was we spun up a company called Vitech, which is a technology company. And essentially what it's done is it's created some really very clever point of use devices, we would call it, in terms of storerooms, being able to walk into a storeroom, pick up an item and walk out again, and then the system recognizing it, which then allows us, with all of that control in these various systems, to create digital twins of inventory. It then allows us to create those digital twins and push them back into other systems. So it's all about control. It's all about how do we put more automation and control in, so it allows us to create great data, which allows humans to make better, more easy decisions across what essentially now is becoming lots and lots of different data points. And by doing all of that, essentially what we can then do, and we've started to build alongside Digital Supply Chain Hub and Northumbria University, we're building out a digital test bed. So essentially, if you took a copper welding tip, say in Nissan, being able to track it all the way back to the copper mine through every stage and iteration, which then allows us to be able to know, because we've got great data coming in the bottom, because that's what Vitech and NBT do, we can push all that back down, which means we can send signals back down the supply chain. And if we're pulling production data from the end user into our system, then essentially we're starting to get a better picture of what we need coming this way, but also then we can bring data the other way from the suppliers. So essentially, we know what's in the bathtub, and we can turn the taps on or off because we can see the rest of we can see what's in the pipes essentially. So that piece is a starting point. We've been building that for the last 2 years. But essentially what we're doing is, and what's been really interesting about that process is we're just creating a lot of data. And essentially, I've always seen it as almost a linear thing of being able to see where a part is, whatever that part is across the supply chain. But actually, what it starting to allow us to do is to build a large language model to use AI to start to generate really good output as to what people need to acquire every day, or what they don't need to acquire, probably more importantly, and therefore really start to eradicate that problem around overconsumption and waste. So essentially, that's what we do, and I think I'll probably just leave it there because we'll get into some questions on it.
Yeah, definitely. Yeah. Right, brilliant. Thanks, Toby.
Thank you.
So hopefully we're going to now move into a little bit of a Q&A session. So hopefully that has given you a little bit of an introduction to different perspectives on some of the challenges that supply chains are facing, and also some of the sort of areas where industry, technology and in the logistics space are working on it. So I'm going to sort of ask a couple of questions on the panel, and then I'm going to hand over to the audience as well if you've got any other questions to our list of panelists here. So I'm going to start off probably to Clive, yeah? Clive, obviously, great work you've been doing in Cranswick, lots of really interesting things that's going on, but, give me one or two sort of aspects of how digital innovation and digital technologies are really helping you in Cranswick address some of your challenges. I know you touched on that a little bit, but just give us a bit of a flavour.
Yeah, I think we've got projects ongoing throughout every sector of the business, really. I think I mentioned we've got sort of 15,000 colleagues within the business, and there's a lot of key areas where we're looking to develop sort of digitalisation, connectivity and AI. Simple applications like when we're bringing animals into the lairage, we're using AI now to make sure that the animals are not stressed, there's no slip, trips and falls, that sort of thing. We're making sure that they're treated with respect. We can see all of the welfare officers, how they're treating the animals and how they're going through the system. So that sort of starts at the front end, going through the sort of processing line where we've got veterinary inspection. We're introducing sort of AI in the veterinary inspection area. And even though it's government controlled and they're, validated inspectors, we can see that the human, in most aspects that we're looking at, the human's probably 85% reliable. AI can get up to about 98%. So we're starting to adopt all these methods right through the business. We did a project with Digital Supply Chain Hub where we were looking at a certain supply chain. It was Sainsbury's Taste the Difference pigs. I showed you that complexity. But just using digital connectivity and AI, we could reduce waste in that area by 20, 30, 40%, increase sales and increase profitability. So making the system simpler, really.
Brilliant. Yeah, those are really good examples and nice to see. I mean, from a logistics perspective, Phil, again, what's your perspective on how much the sort of logistics sector is adopting digital? What do you see as the next things that sort of are coming along in that space? What are your views?
Yeah, the digital journey has been running for a while in the sector, but it started, as many improvement areas do, really probably more at the micro level around how you improve operations, how you improve processes, and particularly how you create single versions of the truth in terms of information in supply chain. and I think that, Toby, I think that was building on really what you were saying. I think they're very much the next step, though, and this has been the really interesting stuff that we've been doing together, is to look how you can achieve really much better results across multiple supply chains through collaboration by using digital technology, again, to create a broader single version of the truth. If you look at decarbonisation in the UK, one of the features of the UK logistics industry has been a pretty high amount of empty running, and that's persistently been there for a very long time. The program that we've been running using digital tech, allowing organisations to collaborate with one another in real time and in a way that fits with the pattern of their operations, I think is really encouraging. And I think those kind of pan-sector areas are where it's going to go next.
Brilliant, that's really useful. And Toby, just to pick up, obviously you've worked a lot with the Digital Supply Chain Hub, you've worked a lot with Innovate UK projects. I mean, what has been the big impact you feel that these sorts of programs are making on helping UK transform their, towards digital and those sorts of areas? And what do you think sort of these programs are doing in terms of helping all sorts of businesses?
I think it just encourages us to do it, Tim. I think at the end of the day, we set out and we had this idea about where we wanted to go. We talked about it before that, suddenly overconsumption stuff becomes a talking topic within the business. And I think you start to then apply yourself to go, well, how are we going to resolve those issues? And having something like Digital Supply Chain Hub, not only from a grant funding point of view, allowed us, and that's a little bit to what Phil said, it allows us to start to collaborate with other people as well more effectively. So to me, I always say with anything in our business, there's two things. There's the cash piece and then there's the network piece, and it's how do you bring those together? And I think working alongside Innovate in the first instance and then with yourselves, I think that's helped, So it allowed us to bring somebody like Northumbria University to the party. It allowed us to look probably as an SME bigger and connecting to people far more quickly, and certainly bigger corporate where we, it's often harder to get in as an SME. You've got to prove your worth before you do that, and vehicles like Digital Supply Chain Hub have probably allowed us to get to that point quicker. But I think as well what it's also done, and it's interesting, and I recognise some of the people in the room here, is it's just allowed other people to come to the party and challenge and add to the piece as well, and give their thinking on where we're going in our direction. And in all of it, the building out of the test bed, which is quite a difficult digital piece, the most interesting piece has just been the thinking that's gone on behind it, and actually how much I've learned from the whole process, I think.
Yeah, brilliant. Yeah, and I think that collaboration theme probably is going to be one we'll pick up more and more through the day, yeah, in terms of how different organisations are working together, but also across supply chains. So I'm now going to open up for any questions to the panel from the room. Yeah, I think we've got a roving mic, which Jack's handling amiably over there. So I think there's a question just in the middle of the room here.
Question for Clive from Cranswick. Where's the biggest opportunities for reducing waste in your supply chain?
Sort of figures in the UK pretty well published that we're wasting 9.6 million tonnes of food every year in the UK, while there's about 8 million people in food poverty. We're working on projects where, just to give you one example, there's so many, but we're working on projects at the minute where we're using digital sensors within each one of those packs. So what we're looking at is location, we're looking at spoilage within pack, we're looking at temperature within pack. You won't actually see these sensors. When we started 4 or 5 years ago, they were quite big, but we're reducing that. So the tech's coming to help us. So what it gives us when the products leave our factory gates, if you like, it's sort of invisible. We get branch complaints from retailers, we get customer complaints and so on and so forth. But if you think that we've got 40 million packs out there, the vision is that we can see the freshness of each one of those packs. So as we speak, we've got trials going through M&S supply chains, Sainsbury's supply chains, and Tesco supply chains at the minute. So they're going through testing what's actually happening within their supply chain day to day. And where we know that we've got issues, it means that we can directly tackle them, if you like. So a bit like Formula One racing car. These guys, you know, there's 110 million streams coming in every bloody second. That's how they can achieve 1,000th of a second over 3 miles. Small improvement, but we can really start to deliver, you know, reductions in food waste.
Brilliant. One last question for anyone in the audience before we wrap. Yeah, just one in the corner.
Hi, my question is to you. Sorry, I didn't get your name. I came in when you were a guest.
Toby.
Toby. My name is Choma, and I live in Newcastle. I worked for NEPIC, a couple of NEPIC Teesside. But currently I'm working for the University of Exeter. So my question to you is around overconsumption, because that's one of the key points that you made during your discussion. Working with clients, what kind of conversations do you have with them about overproduction? And how do you convince them to look at their production or their business model differently to avoid overproduction and inherently overconsumption? And especially given that that's how organizations make more revenue and that's how they satisfy shareholders.
That is the question. That's a really, really interesting question. So, yeah, so we're looking at the consumption that our clients are taking from us. And actually, in this day and age, that's becoming a far easier question, because as companies start to look at where they create their value, we've been in the last 20 years, you know, very price-oriented. We've got to buy the cheapest product, and therefore we'll buy lots of it because we get a better price. Now people are stopping looking at that, and they're looking at how they're doing things, and then actually the value that sits on the shelf. So if you look at our largest client, in just their in one of their sites, they had £4 million worth of stock, now got 1.6 million because we put control into that piece. So for them, that's what they want. They then have nobody managing it because our technologies are all automating all that process. So we're creating a lot of value on site by doing that. The challenge then comes is, well, a great example of it is within the circular piece as well, is that within that, this one client, we were supplying Kevlar gloves. They're buying £1 million worth of Kevlar gloves every year. Now they buy £500,000 because we wash them. And so again, great from a sustainability point of view, great from a value piece, but obviously for the manufacturer above us in the supply chain, that's now half the business. And so that business model, and it's half the business for us as well. So managing that piece is moving us and forcing us towards having to have that conversation about new business models. So for 100 and odd years of my business, we had a very simple buy and supply business model. But now, because we're providing all these services, we're having to charge for the services, and that move towards servitization has been our challenge in getting this to work, because it becomes a real cultural challenge. So whilst and I apologise for my techies who obviously aren't here, but they might be listening, is that the ones and zeros piece is very difficult. The cultural piece is even harder, and then this new business model, this new economic future, because if we're going to save the world from burning because of overconsumption, we've got to find new business models to work to and new economic models to work to. So we spend a lot of time talking that through. So it's very important that you've got, and certainly what we do, a cross-section of people within a business there to be able to understand that piece from a cultural piece, from an economic piece, and then from a use piece as well. It just takes time, and we're moving to that new world. So, but that is the question.
Brilliant. Okay, thanks very much. So thanks very much to our panellists and speakers today, to Clive, to Phil, and to Toby. We're going to wrap up there. Some great questions and some good discussion. So big round of applause for them, please. Thanks, guys. So we're now moving into our second topic of the morning, which is really picking up on the resilience theme related to supply chains, yeah, and how we can use digital technologies to make supply chains more resilient. So in order to cover this topic off, we've got three great speakers picking up with us. So we've got, first of all, Professor Alok Chaudhry from Warwick University. We've got Nishant Raj from Value Chain, and we've got Andrew Dorset from P&G. So I don't know whether you guys want to come up and get sorted out. So the way we're going to run these sessions is we're going to, each of the speakers is going to give an overview of their project and what they've been working on and the aspect, and then again we'll have time for Q&A at the end of the session. So we'll do the three discussions, and then similar sort of format to we did earlier, then have the Q&A at the end. As mentioned, this is one of the key topics, yeah, that we've been looking at in terms of the digital supply chain hub. The resilience of UK supply chains is a key critical topic for industry and for government, whether it be the availability of minerals to support our green technology industries and the growth of those, whether it be just the ability to get materials. We saw the challenges of that through the COVID period, yeah. And I know Toby was mentioning in the last session just, how getting hold of different materials is challenging and how we manage that. So, one of the key things we wanted to do as part of the digital supply chain work and the digital supply chain hub is really understand what we mean by supply chain resilience, and what one of the challenges I was set when we set up the Digital Supply Chain Hub was actually how do you measure supply chain resilience? So one of the things we wanted to set out to do when we asked Warwick University to do was to come up with a method and approach to assessing resilience. So I'm going to hand over to Alok now to talk a little bit about what he's done in terms of the resilience assessment tool, and how that's being used to really understand resilience in UK supply chains. So, Alok, over to you.
Yep, thank you. We have the slides there.
So if you just click on the next one, it'll come up your slides. Yeah?
Thank you. Good morning, everyone. Warm welcome to this session. I think I will have to stay here. Resilient supply chain, actually, that's still a very important topic, isn't it? 3 years ago, we had a whole range of things happening. We have seen Ukraine-Russia crisis through to currently geopolitical situation and trade war going on. Yesterday, I was with a group of pharmaceutical, CPOs and directors of supply chain. And one of the things that came up, that topic of resilient supply chain and mitigating risk in your suppliers, that's still at the top of their agenda, right? And the other day I was talking to people one thing that I say that resilience, this discussion came, resilience, it's gonna cost, but everywhere you kind of hear from people, they're all in cost-cutting mode, right? So there is a kind of, people think that there is a paradox here. On one hand, you're trying to cut the cost, and on the other hand, you're trying to kind of mitigate risk, right? That doesn't go hand in hand. But we developed some example, we provided some use cases which demonstrated that if you are investing X, the return on investment is 10X if you follow some of the things that's been proved in use cases, and some exemplary examples proving those things. So without going into that discussion, starting with how do you go about, and actually how do you go about measuring it? Before that, how do you define supply chain resilience? And before, okay.
Two slides.
Oh.
Sorry, next. Sorry.
Sorry. Can I connect my laptop just in case?
I don't know.
I think if you keep going, you'll get to your slides.
Right.
No.
Oh.
Is there any way to connect this or?
I don't think so. I can check, yeah. We're missing some slides here, yeah? Okay,
Yeah.
yeah. I think we'll just have to, why don't you,
Can you connect it from the laptop? Can you connect it from the center, like it's already uploaded on the center? There's just no way they can connect even with my laptop or anything.
I think we did it earlier with one of the other panels, yeah. So, yeah, what we'll do is we'll swap the order, yeah. We'll pick up then if you were to go next in the chat, and then apologies for this. Then we'll try and see if we can link those.
I will be back. I'm still here. Perfect.
Great. So over to you, Nishant, to talk about total cost of ownership driving modern supply chains.
Yes. So thank you for the introduction, Alok. I'll pick up from here for now. There's a couple of topics that I want to touch upon as a part of my presentation, but just to highlight what Alok was saying, supply chain resilience is a key, and that's becoming more and more important, that everybody knows. One of the key things that has enabled us as a technology provider to leverage, the support from Digital Supply Chain Hub and in general, Innovate UK and others, has been the fact that they've connected us and supported us to work with likes of Warwick, where we have partnered up to actually build out toolkits based on the research that has been done. So from the work that Value Chain has done across a couple of these projects, one of the topics that I want to dive more upon is cost of ownership and scope 3. So doesn't matter what manufacturing company you are. Across every manufacturing company, you have a connected value chain. And across each one of them, you are creating emissions. And the cost of ownership, when you look at it, it's not just based on how much you're procuring parts for. It's actually also based on how much energy is going in. How is the raw material being extracted? How much is that emissions coming from your supply chain? How much is that going with your customers? All of that are quite critical. And we know, as we talk about resilience, that again, throughout at least the last decade, there have been multiple global events that have been happening, and all of them have been impacting supply chain availability and risk. And these are things that obviously, while we can't control the world events, we can prepare our businesses and supply chains to be more robust and resilient. So when we talk about scope 3 specifically within supply chains, it's key to understand what is that. So to start off, scope 1, 2, and 3 are key topics that are talked about when we talk about emissions and cost of ownerships. And scope 1 is everything that's being created as a part of your production and manufacturing. Scope 2 then starts to link into your energy utilization and more. And scope 3 is effectively everything else. So the net of that is quite wide. So while businesses have already started to do a lot of activities on scope 1 and scope 2, scope 3 seems still a little bit further off. Now, it's very critical to actually understand what the impact of focusing on scope 3 also means, because 70% of business emissions actually coming in from the supply chain. Obviously, it depends from sector to sector as well, but there are actions and activities that you can do. And the key thing there is businesses at the moment don't even know where that's happening. So is it happening with my critical suppliers, or is it happening with my non-critical suppliers? Because if it's happening with my critical suppliers, there's very little I can do about it today. But if it's happening with my non-critical suppliers, then I have an opportunity to be able to understand that and change processes, have alternate suppliers, and more. And that starts to drive the cost of ownership down. Now, this also links back to when you're sending your products to your customers and how that products are utilized, again, and tracking all of that. So from a technology perspective, none of this is difficult, right? So technology already exists, has existed for over 10 years, but it's how do you apply these technologies to get this data and insight for your business. And this is not just about, it's a good thing to do. There are regulations globally that's coming about. And it's, again, not just for Scope 1 and Scope 2, but even for Scope 3, that there are regulations globally that are being applied that businesses have to, fit into. And today, if you're already proactive and are able to put systems in place, technologies, and work with your supply chain, because the key thing is supply chain improvements cannot happen on your own. You have to collaborate with your suppliers to do that. So, and it takes time. So if you start to do that proactive journey and utilize systems to be able to share data, to communicate, to have a transparency between them, that's when you start to become preferred suppliers by most companies, because it doesn't matter which tier of supply chain you are sitting in today, your end customer has a net zero goal. And if you are not qualifying in for that, they will find somebody else. So again, there are different aspects within the businesses and different Scope 3 emissions coming. But again, most importantly, the supplier aspects and the customer aspects start to impact quite a lot, especially the upstream elements linked into it. Now, I don't have a video to show here, but I'll just talk through some of the work that we have done. We've done a couple of projects, and we are currently working with Warwick on another project right now on this as well, where we've actually built very simple toolkits. One of the toolkits which we have as a part of our core platform, it actually connects onto the ERP system of any manufacturer and maps out the supply chain and drives real-time collaboration with them. What that meant, and this is something that we were doing even prior to this discussion. Now, what that meant was, because you already knew who the suppliers was, what they were sending to the customer, how frequently, what the weight of the component was, and so on, we can do an upstream Scope 3 for them, pretty much real time, rather than getting an average value out. And once you start to see that data coming from your supply chain, you can actually start to make better decisions. We've also built a very simple self-driven toolkit where you can actually take a CSV and upload your supplier data and can get the feedback on, who are the top 10 suppliers in your portfolio that are causing your maximum emissions, which products are actually causing that as well. We've built the assessment toolkits, which actually get businesses to assess each aspect of their supply chain based on the research and questionnaires that in the frameworks from the Resilience Toolkit and TCO built by Warwick. And all of these toolkits are available to explore, understand, to get started, and most of them are actually free to utilize. So when you are starting off on your journey, the key aspect is you need to identify where your gaps are, focus on the key aspect that will drive the value for you as a business. Set realistically actionable goals. So, you cannot go and set a goal that you're going to get rid of all your Scope 3 emissions or you're going to get net zero by end of this year. If you need to set realistic targets and monitor and have systems and processes in place to drive that and leverage the available support. And again, Digital Supply Chain Hub has, and the community that they're building up as well, those are the places where you can leverage that support that's already out there. So lastly, if anybody's interested outside of this presentation, you can scan this, register your interest, let us come and talk to us or talk to any of the partners. There's assessments, self-service platforms, and obviously our partner network that we can connect to anybody who's interested in total cost of ownership or Scope 3 in supply chains. Thank you.
Right, so now I'm going to move over to Andrew to pick up on the work he's been doing around showcasing new-to-world biofilm sensors connected to each node of the end-to-end supply chain. We're then going to do a Q&A, right, for the first two, and then we're going to get Alok's slides loaded up, and he can pick up and have his own stuff at the end, so we're organised for the resilience. So Alok is going to try and give us a quick overview or discussion of what resilience is in 5 minutes. Then we'll move into Q&A. So I'll ask him to share through the Q&A a few things. So apologies for that. Look, over to you.
That's a classical example of too much of automation.
Yeah.
There is no room for manual intervention. So that's the world we live in. They can't really fit in my slides. I don't know. Okay. So talking about 3 points, we started talking about resilience. First of all, we needed to define resilience. What do we mean? What do we mean before, and what do we mean now? Right? There has been a lot of terms that's been coined. People have started to talk about anti-fragility and buoyancy and all that sort of new terms. But we're not living on the nuances of the word resilience, because that's kind of been used and overused. So in terms of the definition, previously it was pretty much about how do firms effectively prepare for disruption, respond to disruption, and recover from disruption. That's the kind of classical definition of resilience. But when we started to look at it, when we started to talk to people, there was much more to it. So we decided that this is a 6-step process where it's essentially not only you just recover, but you bounce forward. You use disruption as an opportunity for growth. So that's the one element we added, talking about how you will use disruption as an opportunity for growth, and you not only just recover to the position where you were, but you bounce forward after recovery. The second element was you want to do it in a way which is sustainable and responsible, right? So ensuring that in the process of recovery, you are not really polluting the environment or using means of practices which is unethical. So ensuring that you are responsible and sustainable. And third thing, which was to how do you ensure that you have learned from those disruptions so that you are adapting for the future risks and so on and so forth. So redefining in terms of the ability of supply chain to effectively prepare for, respond to, recover, bounce forward from an unexpected disruption, and grow sustainably by utilizing natural and social resources responsibly and learning to adapt for the future disruption. And building on that, we developed a framework. That framework where sustainability, leadership, and a strategic alignment were the 3 core pillars, right? So disruption gives you the opportunity to kind of assess your strategic alignments between your supply chain and your business. That's so important, right? And that is built on 3 different phases. So you have got the readiness when disruption has not happened, responsiveness when disruption happened, and then reacting to recovery, right? So 3 phases, and at the same time, you have 3 set of strategies. And then we assess the supply chain. So again, in that process, we kind of collaborated with more than 50 companies from across the UK. We looked at different practices. We developed supply chain capability model and developed those supply chain capability into 7 different areas that basically focused on supply chain planning, visibility, collaboration, resource management, flexibility, learning, and adaptability. And that allowed us to kind of develop a digital tool, what we call a supply chain resilience navigator. And corresponding to each of these capability areas, you have got, say, for example, if you talk about supply chain planning, right? You have got the risk identification, risk sensing, supply and demand planning, production planning, supply chain network design, all these things that you need to assess. Yeah. So building on those, we developed a digital tool. That digital tool will kind of help assess your resilience, measure your resilience against each capability areas, against each supply chain capability area that I have just mentioned. And based on that, it should be able to provide a set of recommendations suggesting that where are the areas you need to improve. And building on that, cutting the long story short, what is Resilience Navigator? A digital tool, a digital platform for manufacturing organizations to assess their supply chain resilience. These are assessed based on their supply chain capability, right? And it's a self-assessment process. So basically, you either sit one as an individual, as a supply chain manager, or you can sit in a group, and you can go through each of the questions that we have corresponding to each capability area and respond to those. Unfortunately, I don't have a visual demonstration, which I can't, but at the end of it, once you have done the assessment, you will come up with a resilience score, not only the score overall, but corresponding to each supply chain capability areas. And then it is provided with you root causes, that the areas where you need to further improve on, and recommendation engine provides a set of corrective actions which will allow you to work on. You can use this tool to kind of build up your case to your managers whether further investment is needed in supply chain resilience. So again, it's very descriptive answers to compare. It's a simple interface. You can benchmark yourself. And at the end of it, you would be able to download a PDF report which will give you 360-degree view of your supply chain capability and how you can further improve your supply chain resilience. So I think that's from my side, I think.
Yeah, brilliant, Alok. Yeah. Very good, yeah. And well done without the slides there. So we're now going to move into Q&A. I mean, I think just to position it, I mean, I think there's really been three interesting perspectives here. From the point of view of end-to-end visibility and obviously the resilience of supply chains to ensure there's no biological infection and problems with the supply chain. Nice view in terms of the whole ability to look at Scope 3 differently and how that happens, and then the framework that Alok talked about. And I would recommend, if you do get a chance going onto the Digital Supply Chain Hub platform, to look at that framework which is on there. It's dsch.uk if you want to connect onto that. So just picking up on a question from me, and then I'll open it up to the audience. So, Nishant, I mean, what do you think are sorts of been the sort of key things that have helped you in terms of the sort of link into the Innovate UK sort of network environment and the digital supply chain area, in terms of developing what you've done in relation to your tools and solutions, There should be a second mic knocking around.
Okay. So again, the support that's available is quite great, not just from a funding perspective, but also connecting the right problem statements and with partners and academic partners as well. So for us, while we've been in the supply chain technology development for some time, but when we look at the key issues that are impacting businesses, and we take a technology perspective in terms of, okay, what can we do from a tech perspective to actually make it simple, traceable, and then what we have leveraged from the DCH platform and the support and from Innovate UK is again being connected to the right partners and the community to be able to leverage that knowledge to then build that out into tools to then be able to bring it to our customer networks and partner networks as well. So it's key to be able to connect solution providers like us with research bodies and academic providers like WMG and the community that DCH is building as well to be able to really bring something out that businesses can adopt. Brilliant,
thanks. And Andy, I mean, what's the sort of next steps for you in relation to this end-to-end visibility piece? Do you see this rolling out across P&G, or how do you see it developing in terms of, now you've done that piece of work? Just interested to know.
Hopefully, yes. But, I mean, like everything, I think the hardest thing was proving that it worked in manufacturing demonstration. No one would believe us it worked in a pilot plant or the lab. I mean, it's all good that we got that data, but it was only when we built the manufacturing, setup that we have that I showed on the screen earlier, that people started to believe that a random contamination could happen. And it was triggered first by the sensor. The digital platform then sent emails out. We then followed up and did whatever testing we needed to do. And we confirmed it was a contamination. So that was great for us, not great for the business, but nonetheless. But the fact of the matter is, having a sensor that could detect real-time contamination is a big thing. So we got senior management support to expand it into 3 more sites. So not just London, but we go into 3 different locations around the globe, with a view that we build another manufacturing demonstration and prove that it works in different chemistry in a different context. And then if that works, we will expand.
Okay, really good example. And look, I mean, the tool, it looks great. I know not many people have been able to see it today, but and obviously does some great things. But I know you're working a lot in the risk and resilience space, yeah? What are the sort of things you see as the biggest challenges to addressing risk and resilience across the supply chain, and what are the sorts of things you're looking at to address those?
I think again, coming back from multiple industries which are literally hyper competitive. You talk about pharmaceutical industry, you talk about automotive industry. One thing that has come very, very clearly over the last few months, I would say, and it's not the matter of few months, but it's around compliances, your supply chain compliances, your regulations, your geopolitics happening across the world, the trade deals that's happening, that's impacting supply chain, that's a big coming up. But the question then is these are all linked to each other, right? So what we are essentially talking about, having a clue, having a visibility of your supply chain, your multi-tier supply chain, that visibility where you're talking about your suppliers, their suppliers, and tier down the line. We have amazing solutions provided by tech firms, but unfortunately, in my experience and hearing complaints from the people, those are with very low confidence. So I think the challenge there is still around supply chain visibility and multi-tier mapping, being able to navigate through those regulations and compliances. If you talk about pharma industry, multiple compliances, that is kind of really at the top of their agenda. You talk about automotive industry, UFPLA, that is coming up big at the moment for them. So yeah, I think I would say if I have to prioritize, I think that these two things will come at the top of my agenda.
Yeah, it's interesting, isn't it, that that multi-tier visibility across the supply chain is a common theme, and I know Andy was picking it up in terms of using sensors to visualize the supply chain with suppliers and stuff. But when you get to more complex, broader networks, it gets more difficult and different technologies are needed, and I know there's a lot of work going on in that. But critical, and obviously we also see collaboration as a very important part of that, how you work with your suppliers and your organisation. So, I mean, Andy, maybe in terms of the collaboration that you had across the different organisations and the willingness to share information and data, maybe just a bit of a question around that. Was that a challenge, or was it something that you found that you managed to work through?
It was a challenge. I mean, but what we agreed was, with all the partners we work with, we have a CDA in place, so we can share openly data between the two parties. I think working with our supplier, obviously they were a little bit nervous about sharing too much data with us, but on the other hand, it was with a common cause. So we were all learning in the space of, can we measure microbial contamination? So they were happy to share the sensor data with us. They haven't shared any of their other process control data. I don't need to see that, but nonetheless, the critical stuff to allow us to see, is it fit for use? Can we unload it? Can we use it? All of that has been absolutely critical. But the key to it was indeed CDAs. In fact, we have CDAs in place with all the partners because with University of York, they have a lot of IP and a lot of know-how that they brought to the party. We're using their sensor to build the industrial scale sensor. So there's a lot of legal agreements, I would say, in place between each of the parties, which were needed so that we could share data openly.
Yeah, it's interesting. It's getting that framework in place early on, isn't it, right, to sort of see how that works. Anisha, how about you, and in terms of your Scope 3 work and the tool you've offered, how have you worked with organisations to ensure they're confident about you being able to hold their data, share their data, and enable that sort of getting information? Because Scope 3, I know, is a challenging area in terms of being able to get actual data, which you were talking about earlier.
Yeah, so I think that's one of the USPs that we already had as a business, because prior to even those discussions, one of the core things that we were offering in the market was a supply chain collaboration platform, which is already in use in aerospace, manufacturing, construction, and other sectors. So the Scope 3 became an obvious add-on to go on top of what was the baseline of actually enabling collaboration between customer and supplier. And it allows for multi-tier supplier collaboration. And what we have seen, and we've always heard when we speak to new customers is, oh, but my supplier is a much larger organization than I am, right? So why would they actually share that data? But in hindsight, actually, we've had big material suppliers actually share that data, because it improves efficiency, transparency, and productivity across the supply chain. And everybody's trying to improve that. And we're starting to see that knock-on effect. So that collaboration aspect to enable. The other thing to notice is you do not have to start to try to get to that level of collaboration transparency with every supplier that you have. You might only need to start with your critical suppliers initially, with the ones that you spend most with, the most you engage with, and go from there. And when you're able to showcase the efficiency and productivity improvement and that relationship improvement, there's no reason why they won't. And that's what's enabled us to actually tap into that existing architecture to then further expand on to build that scope 3 element.
Okay, yeah, brilliant. Yeah, so it's a good example of actually how you've started to overcome those challenges. Good. I'm going to open out then to the floor for any questions. Yeah, we've got a roving mic, so thanks. Any questions from the floor to our speakers here? Yeah, there's one over here at the front.
Hi. Question for Nishan. So you talk about the energy. I didn't realize it was such a big problem, and it's always good to classify this. But what is the solution? What solution do you offer?
So we only offer the availability to actually see where your emissions effectively are happening within the supply chain, right? And again, when we talk about energy, that goes into more of a scope 2 aspect, which sits outside from a supply chain perspective. But one of the things that when we were speaking to Carbon Trust and others, they're saying that one of the simplest things that businesses can do is actually look at the energy suppliers and actually switch into renewable energy. That's bare minimum that's already available for companies to start to do. But I think the biggest topic comes in is just trying to understand what your current position is with any of your emissions in scope 1, 2, or 3. Until you identify that, you don't really know what actions do you need to take to impact. And to do that, there are assessments that have been built as a part of the research that's been happening in the community that companies can do and speak to advisors as well to actually get that initial starting point.
Brilliant. We've got time for one other question. Yeah, just over here in the middle.
Actually, I've got loads of questions, but I've only got one, and that's to Andy. So I'm going to go to Andy. I could ask you all questions. Andy, congratulations. It's amazing what you've done. But I wondered, there's something that kept in my head, worried about, which is, what's the contract with the other partner, which is obviously superintelligence? If the AI is now allowed to be able to use and analyze, how are you going to protect them from, how are you going to stop it from being able to actually mine your data from in terms of formulations and things?
Great question. Maybe I'll turn it over to expert Roel to answer that one. But I mean, the algorithm we're using at the moment is a very simple algorithm, he says. And it's not that sophisticated, but it's sophisticated enough to recognize when a bacterial growth has happened. And we verified that using some of our pilot plant data. Now, could it go further? Could it potentially? Yeah. I mean, that's a great question. I'm not sure I have a good answer for you, other than obviously it's one of the few algorithms that we've built into that platform. We control what happens and the tags that come into that platform, so there's no formulation data going in there, for example, he says. But equally, I think it's a fair point, yeah. I mean, I'm not sure I know how to answer that fully for the future, but it's certainly a watch out, for sure.
I mean, just my comment really on that one is, you have to move forward, don't you? And with this is now this knowledge that superintelligence, as I prefer to call it, is sitting there waiting, and it's that terrible situation we're in at the moment. But congratulations.
Yeah. No, thank you. I mean, the next step for us is actually to even build some models integrating all of the data that we've got, not just the sensor data, process control data, quality data, supply chain data, to actually even be able to predict the conditions by when a microbial contamination might happen. Now, we're not there yet. That's very much the next step. But of course, superintelligent AI all comes into play there, and it's a good watch out.
Brilliant, thanks. And I'd like to sort of say thanks very much to our speakers, to Alok, to Andy and to Nishant for some really interesting perspectives on supply chain resilience and what they've been doing. So thanks very much. Round of applause for our...
Brilliant. So we're now going to move on to the final session this morning before the break. And this session is on sustainable and... this session is on sustainable and resource-efficient supply chains. Don't know why we're getting the wrong people.
It's supposed to be the middle one, essentially delegating instead, but she didn't tell me who it was.
Okay. So, can you just move the slides into the right place while I'll get sorted out, because it seems to be... right, so we're now moving into the session on sustainable and resource-efficient supply chain. So I'm going to invite onto stage David, Chris.
No,
You're,
I'm not. It's going to be.
Andy. Okay, yeah. You're replacing Chris,
Yeah.
and Sophie as well. Is Sophie here? Hello, hi Sophie. Great. Yeah, please come onto the stage and we'll get going. Yeah. So you're on first. Yeah. They should do. Yeah, we've had some problems, but yeah, I know. So the focus of this session is really to pick up on sustainable and resource-efficient supply chains. You know, one of the things we're seeing in the whole end-to-end supply chain challenge is that Scope 3 emissions, and we've talked about it a little bit earlier, account for some 70 to 90% of all of an organisation's emissions, yeah, coming from and coming from their end-to-end supply chain. So it's been a critical area to look at as part of both the Digital Supply Chain Hub and the work we're doing across end-to-end supply chains. There's no easy way to address this and provide immediate returns for your business. So what we're going to do, I think, is hear three different perspectives across the team today on that. First of all, Flutichem, which is really looking at the carbon chemical supply chain and the second-hand carbon chemicals, and David Bott will be talking to us, Head of Innovation, on that. We're then going to talk on a digital twin for sustainable and resource-efficient supply chain, and Andy Birtwessel is going to be picking up on that. And then finally, we're going to get into the discussion around collaboration, I think, and the need for thinking differently about how we do supply chain to make them more sustainable and resource efficient, and that's coming from Sophie. So I'm going to invite David to start off, and then we'll move into a Q&A at the end of the three speakers. So thanks, David.
See whether it works. No. I love this. Yes, it's me. There is no head of innovation at Flutichem, but never mind. No. I keep pressing the buttons and it goes in different directions. No. That's me. Yes.
Okay, you're good, right.
Okay, how many people from the chemical industry in the audience? Oh, good. Two people who recognise some of the words. Thank you. So I'm going to talk about Flutichem. Flutichem is within 40 days of shutting down as a project because we only got funding for 2 and a bit years. But it has 17 partners in it, which for those of you who've ever been in any partnership will know that that is way beyond the normal number for people getting on with one another. So this is the chemical supply chain that exists at the moment. We start with oil and gas, and we turn it into a whole bunch of things. The seats you're sitting on, most of the clothes you're wearing, the paint on the walls, the carpets, you know, it's just about everywhere. We depend upon the chemicals industry to make materials, all of which are based on carbon. So decarbonising the chemicals industry is a stupid thing to even say. What we're talking about is doing away with fossil carbon. So at the moment, the IPCC puts out, go to the end. So this is the point. 2.6 billion tonnes of carbon dioxide a year is used in stuff, and we don't care about it. We use it in materials which we throw into landfill, which sometimes degrade, sometimes don't. We use them in cleaning agents which go into the watercourse, which then disappear forever. This is working? Okay. Sorry, I'm a moving speaker. That's only 5.3% of the carbon we take out of the ground every year. But that's growing at about 5 to 8% per annum, and everything else is intended to go down. So if we're not careful, if we don't tackle the petrochemicals industry, by 2050, something like 40% of the carbon that comes out of the ground will be going into stuff, and we haven't thought about it. So this was an idea to think about it. There are 3 ways that people usually talk about it, and it's all circular carbon. This is a graph that you'll see from all sorts of people. You can use biomass, but there's a problem with collection, refinement, and the competition for food and land use in general. We can recycle things. We can recycle plastic bags, although we're really bad at even doing the logistics of that. We can recycle tyres. We cannot recycle cleaning products, perfumes, personal care products. We cannot recycle paint. So there's a limit to what you can do there. And the last place we can take carbon from is the atmosphere. We've been storing carbon dioxide in the atmosphere for the last 150 years. We've added about 2.2 trillion tonnes of carbon dioxide in that time. It's up there. It's causing us problems. We could take it back. So we put together Flutichem about 3 and a bit years ago. It consists of a whole bunch of people. It's under the Transforming Foundation Industries program. It was 2 years. It was just over 5 million when we started. It's been a bit less than that. And what we set out to do was to prove that you could build a supply chain that started with carbon dioxide and ended up with surfactants. And this is where the chemists in the room will have fun. This is the thing that cleans things. This is a simple surfactant. It's a C12 at one end, which is usually a source from petrochemicals or palm kernel oil, and ethylene oxide at the other, which is a hydrophilic end. This simple little molecule is traded around the world at about 1 billion tonnes a year. And it's not the only surfactant to use. There's a lot of stuff goes into cleaning products, personal care, and all sorts of things. So what we set out to do is find a different way to make that molecule to prove that you could do it. Right? So this is what happens when a chemical engineer talks to a graphic designer. This is the cartoon of the process. If you look down in the bottom left-hand corner, we had 3 carbon sources we started with. Holman and UPM are paper mills. They have integrated combined heat and power generators on their sites, which are run under the renewable obligations regulations that are now 15 years old and out of date. We had Tata Steel. About halfway through the project, they decided to close down their blast furnaces, so we lost that carbon source, but we kept the 2 paper mills. We had 2 carbon capture systems that we were using. Carbon Clean uses an amine process, which has been around for about 40, 50 years. And CCU International was a pressure swing absorption, solid absorbent process, developed originally in the University of Sheffield and taken into commercial reality by CCU. About 6 months in, Carbon Clean had to withdraw from the project because the regulations that cover emissions declarations and Freedom of Information Act for the Environment Agency got in the way, and they were going to lose their secret source, so they pulled out. Having got the carbon dioxide, and it's worth pointing out that those 2 mills are in Workington and Irvine in Scotland, so a long way from anywhere, we had to get the carbon dioxide and turn it into other things. We have to turn it into that 2 halves of the molecule. One is a C12 alcohol, and the other is ethylene oxide. So we didn't have an answer here, so we took bets on everything. So BASF were looking at turning the carbon dioxide into ethanol, ethylene, and then ethylene oxide. Johnson Matthey and the University of Sheffield were looking at turning that into dodecanol using the Fischer-Tropsch process, which is widely used for making sustainable aviation fuel. CPI, part of the high-value manufacturing catapult, were looking at using biological processes to make the dodecanol, and LanzaTech actually have a business where they make ethanol out of carbon monoxide, but they're also moving towards making it out of carbon dioxide. So having built those components, we then assembled them in Croda, because that's what they do. And then, this is the pièce de résistance. We had Unilever, Reckitt, and Procter & Gamble in the same project, because they realise it's a shared liability that they have to move towards non-fossil carbon feedstocks. They're all making cleaning products, and Tata Steel were coming back again because they were using the surfactants in the paint coatings they use for treating the steel that comes out of the mill. Also involved was University of Surrey, which is part of the EPSRC circular economy groups. They were doing the life cycle assessment, the technical economic appraisal, and the social impact, social risk analysis we ended up with. The Confederation of Paper Industries, there are more than just 2 paper companies in the UK producing CO2. There's lots of other people with CHP boilers. And the SCI, which is where I was part-time working, was responsible for the dissemination and the exploitation plans. So that's the whole project. As I say, 40 days till it ends. What we were trying to do is prove that you could take carbon dioxide from a flue gas and make something out of it. We have managed to prove every step is possible, but without a time machine, we're not going to be able to take carbon and make it into the products, so partial victory. And the idea there was not so much to prove that you could do it, but to show that you could do it. It's like when they flew the planes across the Atlantic powered by SAF, nobody thought they would fall out of the sky, just doing it was good. But more importantly, we're looking at the paper with the learnings we've come out of this project. One of the first learnings is you should never have 17 partners, but we'll move past that. And you should never have those 3 big companies in the room. But also, we learned a lot of things about what we're getting in the way, the regulations, the processes and things like that, the lack of scale-up opportunities, the usual sort of stuff. So we're producing a set of recommendations for what to do next. I won't spend too much time on those, but basically, we've got a lot of learnings out of this. If you do that much work, you find out all sorts of things. But I want to end actually on, we've done some things. We've successfully scaled up something that was at a university to 1 tonne a day. We've developed 2 new catalyst systems. Point out, catalyst systems have been developed for the petrochemicals industry. We need to rethink how we do catalytic processes. What we discovered is that, yes, in principle, it's less of an environmental impact. Yes, it's much more expensive than doing it for the fossil carbon industry, but you'd expect that. And there's no real social impact for doing this because it's all done the same way we do things at the moment. And we're trying to get the message out, and this is yet another example, of the fact that you can't decarbonize the chemicals industry. You have to defossilize it. We have to think of new supply chains. We have to build new supply chains. And if you go to that link on the website, the SCI had gone long ago, so SOCI is the Society of the Chemical Industry. There's a Flutichem website. You can see all sorts of data up there. Right.
That's brilliant. Thanks, David. Right, so I'm now going to pass over to Andy, to pick up on the work he's been doing and with Carbon View on the digital twin for sustainable and resource-efficient supply chains. So over to you, Andy.
So is it that one? Let's see if I can work the. Which one is it?
So this one here should be.
Yeah. Okay. All right. Morning. So I'm not Chris Clemo. So unfortunately, he's got a family emergency. and he told me about it about 11:30 last night. So hopefully I can do justice to this presentation. What I'll talk about is we're a technology company, so we've got software and optimization capability. I'll talk to you about how we use that to make supply chains perform better and more efficiently, and what we want to do, what we're trying to do, is then move that to the next level and make sure that supply chains not only are efficient and effective, but they're also very low carbon emission supply chains as well, so sustainable. And how we're layering that on top of the traditional way of optimizing and improving supply chains. Okay, so SupplyView's been going for about 5 years. The aim is to build some technology and tools to help supply chains, help our clients run their supply chains in a better way, get product to flow a lot more seamlessly, and so the supply chains are easier to manage and they're more efficient. And the carbon view aspect is then layering on carbon management onto that. And what we're aiming at is being able to give a tool to a client where they can see the impact of their decisions, or how they're impacting service, cost, inventory, and carbon, and make an informed decision about how they want to set their business up. The platform we've got is that we've got a data model, so we bring in the data of the existing supply chain, how it's currently performing, so we can perform analytics on it, and create sort of a digital model of the past, so we can see how all the processes are performing, the use of assets, and the variability in the processes and the waste, so we see the past. And then on top of that, we've got planning algorithms, so we can create plans of a supply chain. We've got scheduling capability, so we can model the actual activities in a factory, actually schedule it. We've got clients where we now schedule the factory. But that is those two things, the planning and the scheduling capability, are the backbone on which then to put on top the optimization capability and simulation. So we can actually define how the supply chain should be planned, convert that into a schedule as a model, play around with the optimizer and simulation to have different methods of replenishing, different setups, different parameter values, so that you can make some choices about how you want to set your supply chain up. And then the output of that are basically your planning decisions, which can be sourcing or routings, but also the parameter values and the settings that you put into your planning systems and your scheduling systems, so you will get the results that you're expecting from the modeling. So we've got that capability to create models of the supply chain. And the problem we're attacking is just supply chains with noise, variability, too much stock, intervention, maybe batch sizes too large, so lumpy processing. I think what we're seeing is there's been a huge amount of technology investment in supply chains in the last 10 years, but a lot of these symptoms are still there, and obviously the world and the context, markets are more volatile, and actually lengthy supply chains are less reliable. So there's probably more noise and variability in supply chains than there were before. We're actually seeing inventories are higher. Probably as a general statement, there's probably more inventory in supply chains now than there were 15 years ago. So what we're trying to do is attack the root cause of the problem and not sort of calculate buffers and just plaster over the problem. So we analyze the uncertainty, we analyze variability, and we apply strategies to try and stabilize the supply chains, stabilize processes. That will make the supply chain flow better. Then you can take buffers out, then you can take resource out, and you become more efficient. So that's the basic approach, is to really attack the root cause of variability and uncertainty. And then we do it with, again, a traditional approach, is we start from the factory, we design production wheels, so you get a drum beat, and we synchronize all the activities in the supply chain to that schedule drum beat. The planning tools will govern the way demand is placed on the factory, so it comes in line with the timing of the factory lot that's in the schedule. So we can collapse time, so we don't need scheduling frozen periods, so the supply chain can become more responsive. That will take inventory out, and then the factory there's less firefighting going on. With the scheduling tool and with some of the simulation capability, we make sure that the schedules are very attainable, that they're robust. We analyze the performance of the lines, look at the variability of the performance of the lines, and make sure the schedule is highly attainable. And then you're taking a lot of the noise and the variability out of that process. And then once you've got that, then you can start looking at resource levels, efficiencies, and you should be on a sort of a nice improvement path to just making your supply chain more and more efficient. So we've been doing that, and part of the way through the process, we won a Innovate UK grant for a carbon view product, which is to basically take the same approach, but bring in all of the carbon data so that we can see the processes that are causing carbon or carbon waste, and bring those into the same optimization algorithms so that we can then run an optimization either on service, what's the highest service supply chain, or what's the lowest cost, or what's the lowest carbon emission supply chain. And you'll get different results. And it will depend on the processes and the waste and where carbon is being burnt. So we also work with Tata Steel, who also disappeared from the process. But it was interesting when we looked at the Tata Steel supply chain, the most carbon efficient way of setting up their processing in their factory was actually to build a lot of finished goods inventory. And what you were doing then was limiting all of the extra logistics moves because lack of availability of finished goods. And the storage of the actual steel wasn't causing any carbon. So it was a very big batch, high inventory supply chain was actually the lowest carbon efficient supply chain. So that was the choices. Then that's where you get the business choice. Do I want to have lots of finished goods to save carbon? It was actually giving high service, but there's a capital cost of having all that inventory. So there's, again, trade-offs on how people want to set up the supply chain. So I think to deliver this for a business, when we're setting up the models and the optimization capability in the digital twin, you have to understand what causes cost, so what activities cause cost, if you're looking at batch size and manufacturing frequency, what other costs do they impact? And it's the same for the carbon. It's looking at all of the activities within the supply chain and understanding the drivers of the carbon emission, building those into the model, and then you can start optimizing and modeling and simulating and setting up the supply chain you want. And the aim for us with our clients is to bring all those models and those trade-offs into the decision-making meetings, so into the S&OPs, into the planning meetings, where people should have policies about how they set that up. Are they going to, like in the good old days when I worked before, you were asked to consider environmental issues. So people would put a couple of models on the table, choose the lowest cost one, and say, well, we have looked at the carbon efficient one, so we've considered it, but we'll go for the lowest cost. But if you want, I think carbon is going to become more important, and I think people need to see the trade-offs and understand there may well be a small cost impact of going for a more sustainable supply chain, but you need to put that on the table so people can make that positive choice. What's next? Yeah. So what we've built into the modelling and the optimisation. So the curve before was a sort of a service and a cost curve trade-off. So now we can create the carbon trade-off curve as well. So people can see for a certain cost, what is the carbon emission, carbon impact, and where's the sort of the sweet spot that you want to set up the supply chain. So you don't necessarily want to go for the lowest cost. You may want to go for a slightly more environmental friendly setup, and then understand if there is a cost impact, what is the cost impact of doing that. So I think the other point is we're doing that for people's their own factories. We've also got clients where they don't do their own manufacturing, and we're asking their suppliers the same questions about what are the things that cause setups, what are the things that cause costs, what are the things that cause carbon, and making sure that the way the demand is placed onto suppliers by those companies is going to help the efficient operation of the of the suppliers. So I think the same principles of whether it's your own factory or your inbound material supplying factory or finished goods supplying factory, I think the same principles all apply. It's in the handover, it's understanding what causes cost or what causes carbon, and it's organising the way demand is placed onto those factories to make sure that the factories can operate most efficiently. And that's basically the principle we take throughout the network. So all of this is very possible. I think our clients still tend to focus on customer service and cost. Getting all of the carbon data together with all of the cost data and understanding the drivers of carbon is actually a fairly big exercise. And the data tends not to have been collected in that same way. So there is a data collection exercise, which is it's a barrier to getting that. It's not necessarily a big barrier, it just needs a bit of focus. And I think what we're seeing is if there's it's almost it's a leadership and a way people want to run their businesses. You need that leadership and direction to say you want to be managing your business in this way, to direct the business to get the data in the right shape, provide the data to do the modelling. So I think it's creating the use case, creating the rationale for doing this thing is such an important aspect of getting it done. But we're continuing down this path. I think we strongly believe that building in carbon and sustainability into the digital twin and having this modelling capability is really important. And we've won the sort of the follow-on grant from Innovate UK as a Carbon View booster grant. So we're going to be taking this further. We're going to look at how we can make it easier to get the data, how we can integrate it more into the modelling capabilities, and providing the reports and the trade-off models for management so they can make these decisions in a proactive way. Okay?
Brilliant. Thanks, Andy. Brilliant. So now we're going to just pick up on our last speaker in this session. So Sophie Walker, Head of Strategic Partnerships and Open Data at Manchester. And we're going to talk about the role of data and standards to support more sustainable and resource-efficient supply chains and how collaborating across supply chains can transform how we use all that data. And I think that second bit I'm particularly interested in. So let's, over to you, Sophie.
Thank you. Okay. So I'm just going to say that we also work with Tata Steel, so they get a kind of gold star or something for collaboration. And also, Andy, thank you. We haven't coordinated, but I feel like he teed me up perfectly talking about leadership and data challenges. So I was asked to come and speak about sustainable and resource-efficient supply chains. And to me, carbon is super important, but also I think for me it's about all of those other planetary boundaries that we're also pushing up against or exceeding. And so I think the circular economy is a really useful tool for us to kind of try to approach a lot of those challenges that we're facing. And so if you don't know what the circular economy is, you can come and talk to me afterwards. I'm going to assume you do know what it is because it's a global mega trend or something. But I really like this quote from the WBCSD, which is that all advanced circular economy strategies, from refurbishment to recycling depend on the availability of reliable and up-to-date data, which is currently largely unavailable. And the question is, in our increasingly digital world with amazing tools that we've heard about today, why is the data unavailable? And I think that that is mostly because we, as supply chains and businesses, we've focused very much on all of the accounting and finance stuff and all the kind of the true data about stuff, supply chains, the things that move around and make all the money, has largely been not really kind of focused on. And I think that's because we talk about supply chains, but they're not, are they? They are webs. They are incredibly complex. We saw a picture earlier of your supply chain, which, you know, is absolutely bonkers. And I think that often what's happening is that the data that we're talking about when we talk about stuff and supply chains is abstracted from reality. It tends to be very high level. Where it gets into detail, it tends to be focused on where regulations have required it, so food traceability, pharmaceuticals, allergens, things like that. But it doesn't tend to actually talk about the reality of stuff once we're talking about sustainability. And with sustainability and the fact that it's about the biophysical, you know, kind of environment in which we live in, I think we have to get real. We have to start understanding the reality of our stuff, of our supply chains, of our materials, and that's the only way that we're going to really tackle these things. But at the moment, reporting requirements are exploding. We've seen, I think there was a graph earlier on someone's slide that had a load of different kind of reporting requirements. And the businesses we're speaking to are telling us that they are being asked to report more and more sustainability data, and it is a big burden. But it's incredibly important that they do that, and I'm not against doing that at all. But at the moment, the way that people do that, it's so siloed, it's really time-consuming. Most of the data is single use. And frankly, because it's abstracted and it's being done at the end of the chain, I'd put quite a lot of money on the fact that most of it's probably not actually accurate and is probably at best patchy, but probably just plain wrong. So we need to move away from this huge burden of sustainability reporting to sustainability action. We really need people to start spending their budgets and time and resources on tackling the challenges that we have and not just reporting on the current situation. And to me, that is where collaboration comes in. And we're seeing it, right? I mean, we've heard about an example with Flutichem, where they brought all these people together and figured out how to do something new. There are loads of examples of amazing collaboration happening. And that is going to change this kind of burden of responsibility from the reporting to the action. I really believe that. We heard earlier on about the challenges around data sharing in supply chains and how sometimes that can be a bit problematic and signing agreements and things like that. But the fact is in supply chains, people are sharing data. That's, if they don't, supply chains don't work, right? People know what's happening. They are sharing data with their customers and their suppliers. We just need to make it much, much more efficient for them to do that. Our focus over the last 3.5 years has been on packaging. And we've been working with funding from Innovate UK and talking to over 200 different people in the packaging ecosystem about their challenges around data, with the view to developing an open standard for packaging data that will help to streamline that data gathering and sharing across the entire packaging ecosystem. Because the thing about data standards, especially open standards for data, is that they really help to kind of reduce that reporting burden, because they enable interoperability, they streamline data sharing and gathering, they drive innovation, and they prevent vendor lock-in and stagnation. So we want to move from this, quite frankly, avalanche of spreadsheets that I have seen from people dealing with this to a kind of single source of truth data environment. We want to use circular economy principles on data and systems. So rather than every time you need to do a new report, thinking about pulling up a new spreadsheet and starting again, which is frankly how most people seem to do this, and thinking about how you create a data repository that can be used over and over again, because data is not a finite resource. Let's put aside data centers using up an enormous amount of energy, but data itself is not a finite resource, and actually it'd be more efficient to have a single set of data that you're using for multiple things rather than spinning up another spreadsheet. And the point here is to enable that kind of linking and sharing, because I think for a long time we've been in this data is the new oil kind of mindset of people thinking they need to hoard it and that they're going to somehow make a load of money if they just keep it for themselves. That's not where you get value out of data. Data is valuable when it is shared and linked and integrated with other things. And I think we're starting to see that, and people are starting to move into that space, which is really exciting. And this isn't just about industry. It's really important that the regulators, that the voluntary schemes that exist, that the UN with the Plastics Treaty, all of these other bodies that are requiring this reporting also need to think about how to streamline this. Because ultimately, again, going back to that action point, we're not wanting people to spend all their time and effort on reporting. We want them to do the action. The reporting should become more of a byproduct, right, rather than the focus of the intention and the action. And to do that, we have to do it based on reality. And this is an incredibly, some ways, boring and tedious and basic thing for me to tell you, but it's something that's become incredibly apparent to us, is that so much of the reporting is based on determined data. We ask people to tell us, is that piece of packaging you're putting on the market recyclable? What is the carbon footprint of that piece of clothing, whatever, right? We should move to asking people for the data about the thing itself, like the real data about it, and deriving the information that we need about it. Age is my kind of basic example, right? If you ask someone how old they are, they might lie and tell you they're 27. And then next year, frankly, that's not true anymore. I mean, it wasn't true to start with. But also, it's out of date. So whereas if you ask people when their date of birth is, that data stays relevant. You can also link it to all sorts of other data, and you can derive other information from it, like someone's star sign, super important, or the school year they were in, or when they might be eligible for pension. We need to do the same thing with sustainability data. I will use recyclability as another example. If I ask you to tell me whether something is recyclable, and you go, yeah, okay, so recyclability is generally based on what's the thing made of and what's the recycling infrastructure in the place that it's being sold. Now, that infrastructure will be different in different countries. So if I'm asked whether it's recyclable or not, the answer might be yes in the UK, whereas it might be no in India or America or wherever. Or it might be yes in India and it might be no in the UK. Instead, if we ask people, what's it actually made of, and we have the data about the infrastructure, just get the system to tell you whether it's recyclable or not. And then if the infrastructure updates, so does the score. That's what we need to be moving towards. And that's the approach that we took with Open3P. We really wanted to take that strategic approach of thinking about what is the core data we're talking about when we're talking about packaging, and how do we develop a system that benefits the entire packaging ecosystem? Because like I said, they are sharing the data, they're just doing it in a multitude of spreadsheets and PDFs and different systems. And we wanted something that would help all of them to do this job better. And we knew it needed to be global because these requirements on these businesses are global. They're having to report to different jurisdictions, different pacts, different regimes all over the place. And we needed it to kind of cover all packaging types. So it's not about looking at just dealing with plastic or dealing with glass or whatever. And this single source of truth architecture enables collaboration across these supply webs because it reduces effort and it streamlines reporting, and it delivers value across the entire chain by reducing all that effort and making it easier for them to talk to each other. It's also incredibly valuable to regulators and the Plastics Pact and people like the UN. And I think that's why we've had a lot of interest from the WBCSD, which is like the organisation that has more than, I think, 230 of the world's biggest businesses, because they're all, their members are really struggling with this, and they've done independent research onto Open3P and have told us that it is really useful for their members to meet their requirements. And it's not just about packaging, because the approach that we're taking, this like actually defining what something is and building the materials and the products together in a real way, works for other things. So we've got a project in the early stages on textiles and fashion. We've got some work on electronics and electrical equipment and batteries, and a bit on automotive. And the fact is that structure, which I haven't talked about today because that's not kind of what I was here to do, but the structure can work across those different materials, because it's about defining reality and sharing the data about reality. So that's me. Please find out more if you're interested. We're on stand 12. It's on the other side. My colleague Julian is there. And I look forward to taking your questions. And I'm talking later as well. Thanks so much.
Yeah, brilliant. Thanks, Sophie. That was really good, and I think a great segue into the Q&A, because we've got three good different dimensions here on the panel now. We've got very much transforming the physical chemical supply chain, through carbon. We've got a really great technology solution that could support carbon measurement and a better management and understanding of carbon. And then we've got the whole challenge around open data and how we manage that. So I'm going to ask a couple of questions, and then we'll move into a Q&A from everyone else. So I want to start just on the sort of chemicals supply chain and the challenges in addressing new sources or reuse of carbon, I suppose it is really, isn't it, in terms of what you're trying to do there, and new sources of carbon. What do you think are the sort of, is there energy in the sector to do this, is there really a drive? Where do you think the sector sits in terms of actually really wanting to address this challenge with all the other things that are going on in chemicals in terms of costs and energy prices and all the other things? What's your view on the desires?
So the sector is made up of lots of companies. They go basically from upstream, where they're traditional refiners and things like that, people like Ineos and SABIC and whatever, and they're looking at the costs of changing with no real return. And at the other end, you've got the users, like the Unilever's, Reckitt's, and a whole bunch of other people in different end-user systems, who know that the customers are beginning to ask for it. And then you've got people like Dow, BASF, and whatever caught in the middle and changing. We wouldn't have been able to put the project together without a whole bunch of people believing it was necessary to do. So you could kind of score off the people on our project as being some of the good guys. There are other good guys as well, because it's just not coordinated. There are trade associations and such which are sort of balance out that supply chain. And one of the things we've been trying to do as a result of Flew to Chem is convene a community of the people who actually care, so that we can get things done. But I mean, the fact remains is that whether we choose to do or not, at some point there will be no more carbon coming out of the ground, or else we're all totally fucked, basically. And when we get to that point, where are we going to get the carbon from? We need to start building those supply chains now. There are three very, very large sources of carbon available to us. What we have to do is rebuild supply chains that start from them, rather than starting from oil and gas or coal, worst of all.
Yeah, no, I mean, really, really exciting in opportunities, I think, in terms of rethinking it and the whole carbon capture aspect to that. Just coming on to Andy, and the technology and the digital twin. What's your views around the technologies available now? Everyone talks about AI and about the latest tech that can support digitization of supply chains. I mean, coming from that space, what's your view around what's going to happen with tech over the next few years, and what are you thinking about doing next in terms of how you develop out your solutions?
Yeah, so the tech is very capable now. I think it is about getting the accurate data into systems. But tech needs directing. So I think a lot more of what businesses need to do is actually define their policies and how they want to operate, and what the outcome they need. And I think that using AI and using tech is probably a more reliable way of bringing that into reality, because I think people are getting in the way of some of the objectives of business. If you want a smooth running supply chain, I think a lot of the variability and the noise is actually self-inflicted by people. Either it's the way people are measured, so there's a lot of siloed measurement of cost instead of holistic objectives. And people have biases and concerns. They don't want to run out of stock, so they intervene in the process. when they probably don't need to intervene. So I think the technology is probably going to, in itself, enable the supply chains to run more smoothly because it won't intervene as much in the process. But then I think it's then down to the, it's more of a management. Management will be more directly involved in running the supply chains because they need to set the policies more clearly, but then the technology follows. I think there's an opportunity there.
Great, yeah, and I think, you know, from your perspective as a sort of smaller tech company, what are the sorts of challenges you've been facing in terms of trying to grow, build, and develop the market for your sort of tech?
I think it's we need credentials and, you know, references where we show we do what we say we can do. So and making change in supply chain is slow, so it takes a long time to implement, deploy, and then get the supply chain to be running in a much better way. So it takes several years to get that credential. So I think that's it's a barrier to a small technology company.
So
supply
that's sort
chain
of the
breaking
benefits
into
and the
market.
credentials
Yes.
and the sort of examples
Yeah.
of what's doing.
Yeah.
Sophie, yeah, go on. If you fire on that as well, yeah. If you want
Yeah, I mean, I totally back up everything you said. So I saw, I think it was part of the industrial strategy kind of document that came out in November. And I was skim reading that recently. Someone said, "Why do you hate yourself?" But yeah, and one of the things in it was saying about how the UK is incredibly good at developing IP, right? We're really innovative. We do a lot of really amazing innovation. We're really quite bad at adopting it. And I wear too many hats, and I also run a small tech company as well. And yeah, I read that and I was like, that is my experience from the last 9 years, is the fact that people go, oh yeah, this is really good. Once everyone's doing it, I will absolutely subscribe to this service. It sounds brilliant. Once everyone's there, just come back and I'll be on board. And it's like, you do realize how stupid that sentence is. And we found exactly the same thing with the supply chain open 3P stuff. Everyone says it's a good idea. Everyone wants to do it. But everybody is waiting for someone else to make the first move. And that's really challenging. And I think, you know, I don't know what the makeup of the people in the room is, but I would, you know, throw it out to you guys. If you hear about great things that are going on, be champions for it in your organization, because otherwise this stuff isn't going to happen, and we need it to happen. We've got so many big challenges. It really needs to land, and I think that leadership piece is so important.
Yeah, and I think really, really good points. And, you know, the whole area of data and collaboration is obviously a critical one, yeah? I think it's been a theme throughout the morning, yeah, which all of the sessions we've had. So is there sort of one sort of tip any of you can give to people in the room or organisations around this whole data sharing challenge and collaboration, yeah? I don't know, Sophie, whether you want to start?
Yeah, I think from a data point of view, I've probably got two main things. One is I think that you almost certainly are rubbish at it. And don't worry, so is everybody. So spend some time and money on training, right? Because honestly, we've spoken to pretty much no one who does this well. And it is so important now. Like, it's really, really critical. And I think it will make and break businesses in the long run. So it's worth investing in. And really actually train up your team so that you can do it in-house as well, and you're not relying on consultants and stuff to do that. No offense to consultants. The other thing I would say is, I think, like the point I was talking about is, like, you don't get value out of the data by hoarding it. I'm not saying you should, like, release all of your secret source information to everybody and, you know, give it to your competitors, but you are sharing data with your supply chains. You should keep doing that, and do it in a way that makes sense for all of you, right? Try to work out how to make life easier for all of your suppliers and your customers, because that will bring more value to all of you, because you'll make the data more accurate, you'll make it easier for all of you, they'll like you more. I mean, there's just so much to be said for collaborating on the data piece, because it isn't all just going to come from you. There's no organization that's going to create all of their own data. So think about how to do it in a way that really adds value to the whole supply chain or supply web. And you know, look at standards and things like that do exist or are in development, and support them, because that will really help you.
David, whether you have a view on?
Yeah, I think the point that enabled us to build the community that made Flutichem work was because we all knew where we were going. So I would always start with the why. I'm a big fan of how and what, but because that's how you deliver it. But if you don't align at the beginning and have a shared goal, you will not work. I mean, we've run into some absolutely amazing problems over the last, well, even signing the collaboration agreement was an interesting lesson in politics. But because everybody was on board, even the lawyers, who are usually the most intransigent, got on board with this. And so we ended up with, we had 15 and then we added 2 more, which was difficult in itself as well. But because we all knew where we were going, we wanted to make a point that if you did it, it would work. And the second point is the culture of the thing. I mean, the famous thing about culture eats process for breakfast. If you don't have it comes back to your leadership thing. And leadership happens at all levels in organisations. It's not just the leaders who can blame. We can blame ourselves when we're not doing it. If you don't get involved in these projects, and the people who have been involved in all the work packages of Flutichem are actually friends now. And it's amazing to watch, because we're getting to the end stage and we're doing the learnings bit, and everybody's saying, I had no idea that was how a paper mill worked, sort of thing. And that was from someone from a fast-moving consumer goods business, and vice versa. I didn't know where my stuff went. I didn't know that was important. All these I didn't knows are because they listen to one another. So listening to one another is the thing I'd go for.
No, that's really good. I'm going to open it up now to the audience here for one question. If anyone has a question in the audience before we close on the session. Anybody? I think, there's one question there from Ben at the back.
And I'll ask just what. So this is a really complex challenge that we're talking about, and everybody acting in individual silos can demonstrate some individual improvements, but is that enough? And what might an organisation like Innovate UK do to help address the bigger challenge from your perspective?
Maybe a quick answer on that.
So I used to run the programs, were there once, so I know the answer to this. It's basically keep talking to one another. Set the context. The one thing Innovate UK has the right and duty to do is set the context of how all the individual bits work. You make connections. Business Connect is a wonderful organisation, and I get paid for that later, because they put people in touch with one another. It's actually, you can learn so much from other areas. I mean, I first met Andy, 4 or 5 years ago? And we were talking about Carbon View, and I was going, yeah, that's really wonderful. I bet somebody I know will buy it, sort of thing. Just connections. Just reach out, talk to people, push people into talking to one another. Because actually we're all a bunch of raging introverts and we hate being ignorant. And if you're not ignorant, if you don't ask questions, if you don't have a sense of curiosity, you will contribute to making it worse, and Sophie will kill you.
Okay, wow. I've brought my scary persona today. I didn't realise. I think that's, yes, that. And actually, so I was at Packaging Innovations last week, and Stuart from, I've completely forgot the name of his company, Reposit, said, we need to move beyond collaboration. And I'm a big fan of collaboration, but I really liked his point, which was like, actually now we need to move to collective action. So maybe one of the things Innovate UK could do, because I think they're great at helping with the collaboration, is try to then help turn that collaboration into real world stuff, more real world stuff actually happening, and see how we can, because it's not enough to just do it individually. It has to be a joint effort.
Andy, last word, or you?
I agree with
Good. Great. Well, that's a good way to end, I think. Collective action, yeah? So we should all think about that. So thanks very much to the panellists, David, to Sophie, and to Andy, and to their speaks today. So that concludes this session. I think we move back into a plenary now. If you want to find out more about these or what we're doing in the Digital Supply Chain Hub, please come and look at the stands as you go around the room. And I think we're back in here straight after lunch. So thanks very much, everybody.
Take my face off the screen to start with. So just for the next 30 minutes or so, this session's going to cover a bit of an overview of the Climates programme. I'll come into a bit more detail in terms of what the programme is, but the programme, or the title, Building Resilience Through Innovation. So I'm going to put a bit of context behind why we've done what we've been doing. Talk a little bit about the opportunity that we've identified around that as well. Talk a little bit about what we've done, what we've achieved, and ultimately what our ambition is and where we're heading to go. So I'm Martin Sherrington. I'm the programme lead for Circular Critical Materials at Innovate UK. And fundamentally, start with a controversial topic, but net zero is just not achievable without critical raw materials. And you might not necessarily understand what critical raw materials are, but you interact with them on a daily basis. And the clean and digital transition that we're currently going through at the moment to decarbonise our energy, our transport, our industry, is fundamentally underpinned by these materials. And that includes your mobile phone, your televisions, your radios, your washing machines, your cars. They all have semiconductors, they all have electric motors, they all might have generators, they all have batteries, and all of those components or products all contain critical raw materials. Broken it already. So this diagram is getting a little bit out of date now, but this is from a foresighting study that the European Commission did about 5 years ago. And what it does show on the left-hand side is a list of materials ranked in order of risk. In the middle, you've got a series of key products that use those materials, and on the right-hand side are some of the key sectors that these materials are used in. And what you'll notice in the top left there is a very high levels of risk are the rare earth elements, so light rare earths and heavy rare earths. What are rare earths? Well, they are the bit on the periodic table that in your chemistry lessons in school you probably never get down to. Right at the bottom, it's the lanthanides. It's the 15 lanthanides plus scandium and yttrium. And the reason that rare earths are so important is one of their key applications is in magnets. It's rare earth permanent magnets, so neodymium iron boron or samarium cobalt. And magnets effectively are used in everything from traction motors in electric vehicles through to offshore wind turbine generators. Saying they're rare is a little bit of a misnomer. They're not actually rare. The challenge with rare earths is that they're actually quite abundant and they are in quite a lot of large mineral deposits, but they're there in relatively trace amounts. So the challenge with rare earths is actually how you fundamentally separate them out from those mineral deposits, and then you've got a bigger challenge as they're all quite chemically similar, sit together in the periodic table, and it's then how do you actually then isolate those metals from each other. And then there's another big factor to it as well, and it's the sort of the current big elephant in the room, China. So 70% of the world's rare earths are mined in China, and 90% of the global supply chain of processed rare earth elements are in China. The Chinese don't want to sell you an oxide or a magnet, they want to sell you a car. They've spent decades investing in the entire materials and manufacturing value chain to go from mine to magnet to product and out to us. And this has created a huge challenge and in terms of these materials are now highly economically vulnerable and at extremely high risk of supply chain disruption. So what's the UK government been doing about it? So the somewhere. There we go. The approach by the UK government has been evolving over the years, but back in 2022 saw the first critical minerals strategy for many years published, and this then saw the establishment of the UK Critical Minerals Intelligence Centre, run by the British Geological Survey, established as the UK Observatory for the space. In 2023, there was an industry-led task and finish group looking at industrial resilience for critical minerals, which was led by our very own Catherine Bennett, who's CEO of the High Value Manufacturing Catapult, you ever heard of if you went to into one of the keynote sessions earlier. And this identified six, there might have been seven, high-value manufacturing sectors that are all consumers of these products. And ultimately trying to understand where the gaps in the UK supply are. Last year, there was a few interesting things happened. So one, the British Geological Survey and the Critical Minerals Intelligence Centre updated the UK's criticality assessment, and we actually went from 19 materials and minerals classified as critical to 34. So the problem just got quite a bit harder. And then, rather excitingly then, in December, at Resourcing Tomorrow, Minister Jones announced that later on this year, there will be a new UK strategy for critical materials. When the first critical material strategy was launched in 2022 and then refreshed a bit later on, that was when the Climates Programme was actually initially announced as a key delivery vehicle for the national strategy. So, spoiler alert. So the big question here is, well, we're doing all this, but how do we increase security of supply and build resilience for these critical materials, especially for rare earths? And it'll come as no surprise, there we go, to many of you. Recycling. So recycling is the answer. So what we can do is actually take advantage of the situation we find ourselves in, where we've been importing loads and loads of overseas product with loads and loads of critical materials embedded in their components. And that becomes a massive end-of-life feedstock opportunity that we can capitalise on. So in terms of where those secondary sources are coming from, so really there's two extremely big, I was going to say low-hanging fruit, that's probably not the right way of putting it, and then there's some other, so battery electric vehicles, so the SMMT, as of 2024, their figures are showing there's about 1.7 million electric vehicles on the UK roads at the moment, roughly with an average expected life of between 8 and 10 years. Every electric vehicle at the moment has in order of about 5 kilos of magnets. So if you do the maths, that's ballpark 7 million or so of feedstock. As it also happens, internal combustion engine vehicles also are packed full of magnets in their ancillary motors and all sorts, everything from the windscreen motors, but also from the speakers in your car, absolutely full of rare earths. So the actual figure is probably even bigger than that. The second big thing is UK government policy has been seeing massive targets in terms of deploying offshore wind as we decarbonise our grid. So by 2030, the current target is 50 gigawatts. An average offshore wind turbine has ballpark 650 kilograms per megawatt. So if you do the maths, you're talking a potential secondary materials feedstock there of around 30 million kilos, which slightly longer lifetimes, but over the course of the next 25 to 30 years, that material starts to come back. The longer term there, by I think it's 2050, I think the target is to have 115 gigawatts of capacity deployed. So, I mean, that's just then more than doubles what the current feedstock levels could be. The other big one is WEEE, so waste electrical electronic equipment. So I sort of talked about mobile phones at the start, talked about televisions and radios. Loudspeakers and hard disk drives, for instance, are a massive source of rare earths here. And then you've also got huge opportunities as well to look at valorising other waste streams and looking at mine tailings, for instance, and land remediation. There's lots and lots of opportunities to recover rare earths and a lot more in between. So looking forward at the opportunity, so the British Geological Survey is part of the Met for Tech Centre, which was a UKRI funded programme, identified that by 2040, rare earth permanent magnets at end of life could from electric vehicles and wind turbines, are forecast to actually equal expected industry demand. So what that actually means is if we start developing recycling capability now, the UK could actually, weirdly, find ourselves in a position where we could well be a net exporter of rare earth elements by the mid-2040s, which would certainly be a rather strange turnaround, but one that is a really interesting opportunity to go for. But then that takes us into, well, how do we realise that opportunity? So this is where it starts to get a little bit more challenging. So how do we develop a circular economy to make this happen? So there is, right down here, an obvious starting point of actually starting to look at design for recycling, work with the OEMs and actually try to design better products that are more easily recyclable to make the economics of recycling more efficient. But that's not a short and possibly even not a medium-term option. That's going to be a sort of a longer-term problem. So moving up, the first thing we've got to really do when products come to end of life is collect it, sort it, and disassemble it. But that's on its own is a massive, massive, massive challenge. So we've got to be able to actually do that disassembly in an economic way, and that's the fundamentally most difficult part of all of this. But once we have done that, then, well, before we do that, that actually opens up a series of rather interesting innovation opportunities as well around robotics, automation, AI and machine learning. There's huge opportunities to get innovative technologies involved to actually grow that recycling capability. Once we have sorted it and disassembled it, our options could be to go down to direct reuse and actually just take a magnet out and stick it straight back into a new product. That's not as easy as it sounds. It might be possible with sort of larger magnets. It might be possible in sort of offshore wind turbines, but unfortunately, manufacturers do have a habit of updating their technologies and redesigning things, so that might not necessarily be the easy one. Then we move on into, okay, so if we can't directly reuse it, we feed it into short-lived recycling. So can we go magnet to magnet? So in the UK, this is something we've got particular expertise around. So the University of Birmingham, back in the 90s and the noughties, developed a hydrogen processing of magnetic scrap process using hydrogen decrepitation to effectively, I don't think Rob's in the room, so I can say it. Effectively, they've created a massive washing machine drum, effectively that they can throw a load of magnetic, scrap-containing products, and effectively use hydrogen to effectively turn those magnets back into powder and collect that powder, press it back into a new magnet. So there's a company called Hypermag that are in the process of now scaling that technology up. But there is a downside, there is a catch with short-lived recycling the product out is only as good as the stuff in. So if you want a high-quality magnet out the other end of that process, you've got to be putting high-quality material in, and that's another challenge in itself. So therefore, the other option is long-loop recycling. So effectively, take the magnet and turn it all the way back to its constituent metal oxides, and then feed that back in to the rare earth midstream to actually do the alloying and subsequent magnet manufacturing. This is a great process because effectively what it means you can produce oxide grades which are actually arguably more pure than virgin materials that are dug out of the ground in the first place. So it's a really interesting opportunity, and what we've been doing with the Climates programme, so Circular Critical Material Supply Chain, it's a £50 million investment. over the previous 2 years or so, and there's still about another year or so to go on the programme. We have been focusing on rare earth elements for the reasons really that £50 million isn't a lot of money, so we wanted to make sure that we concentrate on getting the biggest bang for our buck, make sure we get a return on investment from that. But also we've been able to complement activities that have been going on with our colleagues in the Faraday Battery Challenge, who have been looking at battery recycling, have been looking at battery materials as well. And ultimately, our aim here has been to seed growth of UK capability for a circular supply chain. So the vision of the programme has been to create a more resilient and sustainable UK by building a stronger supply chain of materials for high-performance magnets and position the UK as a world leader in rare earth metal recycling. In terms of the mission, so we've been basically looking to improve the security of supply of rare earth elements through 4 routes. So we are still looking at it from a full mine to magnet and then back. So we've been looking at sourcing, extracting magnets, processing them, manufacturing magnets in the UK, which is a particular gap in the UK supply chain at the moment, certainly from a sintered side. Recycling high-performance magnets as part of a circular economy, and enabling research into the next generation of magnet materials. And I'll come on to that in a minute. But ultimately, in doing this, we've been building networks of industry, investors, government, and the researchers to actually make this happen. There we go. The innovation themes that we've been focused on. So extraction, so digging materials out the ground in a much more efficient way, doing that beneficiation and actually taking it from ore and extracting out the carbonates and oxides. Processing, so investing in the midstream, looking at how we improve our midstream processing, improving that separation from mixed rare earths into separated rare earths, and doing that metallization and alloying. Looking at the downstream, moving into magnet manufacturing, so how do we make magnets more sustainably, but also how do we improve the performance of magnets. Circular economy, I've already talked about that, and alternatives then. So this is the sort of the counterfactual piece. So really interested in, well, what can we do to look to de-risk supply by not using rare earths, or substitute out rare earths, or find some sort of alternatives. Which is actually not quite as easy as it sounds. So in terms of the programme and how we set the programme up, so we've had 5 pillars. So innovation, so funny enough for an innovation agency, focused on identifying and investing in business-led R&D activities and looking at how we promote research to business knowledge exchange as well, to help grow UK capability. International, so recognising that we can't do this on our own, as we don't actually mine any in the UK currently, so we do need to build and develop key international relationships for collaboration and cooperation and knowledge sharing. Skills, so I think this has been a common theme in a number of sessions today, but it's the sort of the big elephant in everybody's room at the moment. If we're trying to build and grow a supply chain, we need people to man it. There's a big challenge there. And standards. So if we're investing in the innovation environment and we're getting high quality R&D through, leading to next generation products, processes and services, we need to ensure that innovation environment is supported by appropriate standards, and working with our partners in government to ensure that policy and legislation is there to actually back up the growth of the sector as well. And the other one then, working with the investor community and ultimately looking to how we can unlock that private investment to, again, accelerate growth. So in terms of some of the delivery headlines of what we've done, in total we awarded 38 R&D projects to 52 project partners, and that was a £12.4 million grant funding investment with an £18.1 million total project value. We've also run 5 targeted innovation exchange challenges where we had 5 SMEs across the rare earth value chain set with some very specific challenges that they wanted solving, and we ran a process where we've ended up connecting those SMEs with business-to-business or research-to-business solution providers. We've also commissioned and are about to publish a series of innovation landscape reports looking across the breadth of the UK value chain, identifying where the key opportunities are to direct future R&D funding. From a skills side, we have had a strategic partnership with Explore Science Discovery Centre up in North Wales and Less Common Metals, and through working with them, we've managed to grow their Mine to Magnet STEM workshop, which had previously seen about 250 pupils a year receiving the training, and increased that up to 1,500, and we're looking to keep that relationship going and expand it a bit more nationally. From a standards perspective, we've worked with BSI, the British Standards Institute, to identify priority areas for future standards development. Indeed, there's a webinar available to look back on from last Friday if you want more detail on that. From an investor side, we've completed a barriers to investment report about 18 months ago, identifying where the key barriers are as we see at the moment. And we've also done a series of investor networking events. We've also run an investor readiness program as well, in partnership with our colleagues in the Faraday Battery Challenge, to prepare SMEs to raise investment. From an international perspective, we've also done a big piece of work looking at international benchmarking, and we're currently now working with colleagues across FCDO and DBT, and also internally with Innovate UK across our global teams, to actually help understand what we need to do going forwards, and hopefully get some more missions going. And we've also done an awful lot of work with the Canadians as well, including several missions, and also we've had a bilateral funding competition. So just to add a little bit more colour to what we have been doing, so just some project examples to run through. So the top one. It's a first-of-a-kind project looking at decommissioning an offshore wind turbine. So this is actually, I believe, a global first. We managed to, I say we, the royal we, but Magnumatics in the middle, electric machine manufacturer based up in Sheffield, actually produced a prototype offshore wind turbine a few years ago, and they offered that up as a bit of a test bed for European Metal Recycling, who led the project, to try and understand how to actually decommission something which is rather large, I think, to put a slight bit of an understatement, and working with Hypermag in Birmingham to look at how they can actually recycle those magnets, create new magnets, and actually feed it back into building a new machine to actually validate the use of short-loop recycled magnets in an electric motor. At the bottom, so SG Technologies, they make bonded magnets. They're based down in Rainham, down in Essex, not too far away from here. They worked with ZF, automotive tier 1 manufacturer, to actually integrate recycled magnet feedstock into bonded magnets for use in power steering. So that project is due to come to an end fairly soon. In terms of more supply chain collaboration as well, so Ionic Technologies and Less Common Metals, who are both out in the exhibition hall, working with Ford at the moment to actually, the ultimate goal in this project is to actually produce a Ford Puma with 100% recycled electric powertrain in. And at the bottom, a project led by Pensana, who are a UK-registered mining company establishing a refinery in Humberside, have worked with Polestar looking at ways to improve the ESG performance of their mining activities for primary sources. In terms of some novel processing sources and alternatives, so some interesting projects here on the sort of more left field side. So Mine Tailings, Artilium Metals, who are currently scaling up a battery recycling facility up in the northeast. They have been working with the University of Exeter to see if they can apply their hydrometallurgical processes to actually recycle, to recover rare earths from mine tailings. The phytomining, so Fiona, spun out of Brunel University. They are basically using plants to bioaccumulate metals so they can do large-scale land remediation. Really, really interesting. Ionometallurgy for recycling, so Nanobox are currently in the process of scaling zinc oxide recovery, and they've applied their chemistry into the rare earth space. And a bit more work to do, but it's looking very, very promising there as well. And then Materials Nexus, working with less common metals. So again, Materials Nexus are out on the show floor, and they've been using their AI software to look at doing materials designed to reduce the use of heavy rare earths in magnets, as heavy rare earths are currently classified as conflict metals. So that's some of the flavour of what we've done in terms of the impact so far. It's looking very promising. So have we seeded growth? Well, the current evidence suggests that yes, we absolutely have. So our indicative co-investment at the moment is looking at around £174 million, which represents a 12-fold investment at the moment. And hopefully there's only one direction that's going, and that's up. And I think broadly then, where do we want to go? So our ambition really is to ultimately expand the scope of what we're doing, continue to build capability in the UK, but taking into account how we do carefully expand that material scope to reflect the new 34 materials that are on there. We need to understand how to prioritise that. We want to be able to use secondary material feedstocks to build security and resilience in the supply chain through circular approaches, and ultimately the long-term vision here is to actually make the UK a world leader in the recycling of critical materials, not just in rare earths. So, as I said, the British Geological Survey have increased the number of critical materials from 19 to 34. So what we've committed to doing over the next year or so is actually evaluate the current UK industrial landscape, understand what the midstream looks like, and identify where the strategic opportunities are for growth. We also need to identify where the priority materials are to direct future research and innovation funding. So hopefully we can take that 34 and reduce it down into a bit more of a strategically manageable chunk. So in summary, as I said at the beginning, critical minerals and materials do underpin net zero. They are absolutely fundamental for high-value manufacturing. The programme set out to seed growth in the rare earth space for a circular economy. I think we've done that, and circular economy approaches can absolutely enable the UK to have security of supply and increase our supply chain resilience for rare earth elements. So I think with that, I think there's about 2 minutes left. So, does anybody have any questions?
And does it work? Yeah. So you were talking about offshore wind turbines and the quantity of magnets they have inside. Have you also considered the cost of taking down those turbines in this? Because I heard in some countries they decided to leave them there, so recovering that material could be quite challenging. Thank you.
Yeah, I think if you look at it in terms of in the round, I mean, the magnets in a wind turbine are only one small part. You look and you think there's tons of copper, there's tons of aluminium, there's tons of platinum group metals and gold and structural steel, electrical steel. There's a lot more material to actually go at, which in theory will offset those costs ultimately. I think there's limited work you can do in terms of trying to extend the lifetime and life cycle of those turbines, but I think they will have to come back eventually. But yeah, absolutely get your point. So. behind you, Chris.
Critical minerals supply chains are very obviously international and geopolitical by their very nature. Are there any plans for kind of bilateral or international collaborations with other countries? Like Germany is doing a big collaboration with Australia at the moment. Is there something similar planned for the UK? Or is that on the roadmap?
Yeah, it's on the... We've done a big international benchmarking report and analysis at the moment. So we're currently working with colleagues at FCDO and DBT and with the global team at Innovate UK to help us understand what the art of the possible will be. But the UK is also a member of the Mineral Security Partnership as well, which you know is it's about 10 or 15 countries part of that at the moment. So yeah, there's a lot of activity going on to sort of get buy-in trilateral activities, especially in the innovation space. Right, I think on that, I think we'll, before we get kicked out, I will draw it to a close. But thank you very much. I'm going to go, I'll be around by the climates poster anyway for the next sort of half an hour or so, if anybody's got anything else they want to come and ask me. But thank you very much.
I think if you come up, do your speech, and then stay here. Yeah. Sit down and start, yeah. Hello, everybody. Thank you all for joining us today. I hope you've had a good day so far and enjoyed the lunch. I certainly did. So, new supply chains. Now, the UK is potentially in a really, really strong position for thinking about, net zero, climate change, and the new supply chains that are going to appear because of that and as part of that. If you think about our academic base, very strong academic base, and in some extent in some of these new supply chains that will emerge. And the second sort of ingredient element is our ability to innovate at speed and fail quickly and move on and all of that kind of thing means that we can take advantage of these changes in the way that, particularly in power, you think about whether it's hydrogen or electric or whatever it might be, thinking about how we're going to power our future, we can take advantage of our academic credentials and our innovation together. And then the third element is that we've already got quite a lot of large companies. If you listen to the Make UK speech earlier, the level of manufacturing, particularly advanced manufacturing that we do in the UK, and a lot of it goes under the radar and isn't publicly known, but we do have that manufacturing base. So when you combine those three ingredients together, I think the UK has the potential to be a really interesting place for developing those new supply chains and those supply chains of the future. And when you think about what, say, 2050 looks like, what does the sort of industrialized country, what does their manufacturing ecosystem look like in 2050? It's going to be different. It's going to be new, and I think we've got many of the ingredients to make a real success of the UK for that. So today we're going to be talking about that. We've got three excellent speakers to tell you about their experience of different elements of those new supply chains and how their work and their organisations are stepping up to the mark with regard to that. So we're going to have about 10 minutes each for the speakers, and then at the end we'll have an opportunity to ask questions. So please hold your questions for the end, and after you've given your speech, if we can take a seat, and we can have the questions at the end. So, Dragika, can I hand over to you? This should work. Should flick through to your slides.
Which is the magic button?
The arrows, yeah.
The arrows, okay. Well, hello, everybody, and thank you for joining this session. My name is Dragica Kostić-Perović, and I'm a chief engineer at Ricardo, working within the electrification, within the engineering department. So today I will be talking about Alumotor. Alumotor, an electric machine which was developed by a consortium of companies funded by Innovate UK over the period of 2.5 years. Within this consortium, Ricardo had a leading role. We also developed and tested this electric machine. So we like to describe Alumotor as an electric machine that consists of a unique collection indeed, of technologies. And these technologies can be strategically deployed to reduce the cost and to increase the sustainability of an electric powertrain in today's application. And how do we do that? We like to say quite simply, by eliminating copper from the winding structure and replacing it with aluminium, and also eliminating the usage of rare earth metals by choosing the synchronous reluctance topology. This will probably resonate for those of you who sat here through Martin's talk earlier. And what is achieved through such an approach is a synchronous reluctance machine whose performance can be scaled in power, scaled in performance, to make it adaptable, to adapt it to a number of applications across many markets. In other words, what we see here is not the only and the final solution. This can be changed based on customers' requirements. More importantly, this machine can be delivered through a supply chain which becomes independent from geopolitical pressures, purely through the approach of using the aluminium and not using the rare earth. So Alumotor, being a sustainable and low-cost solution, has a market potential of 1.5 million units across the light-duty and off-highway sectors annually by 2035. This is the analysis undertaken by Ricardo. And when we were working on this analysis, we did the following. We analyzed the market conditions. We then assessed the market fit of this product, of the Alumotor, for those market conditions, and then identified, assessed, looked at potential target customers. When analyzing the market conditions, we have found that the key drivers to the security of material of the supply chain is the security of the material supply, also sustainability impact, and most importantly, the cost implication, cost reduction. In a traditional permanent magnet machine, security of supply of permanent magnets and copper easily comes under threat because it is prone to geopolitical influences dictated by the state of the political tensions dominating the world at any one time. Thus, a design which eliminates the use of critical raw materials reduces the dependence on relations with countries that are rich in critical raw material. And thus, such a design will be the one providing advantage and benefit to its manufacturers and indeed to its end user. Such a design also reduces the environmental impact and through specific design approach even improves the recyclability. Needless to say, the cost reduction is, just like in any engineering project, essential. And here it is essential in building a sizable market share of electrified powertrains. So at present, we did not come across another competing product that combines this particular collection of technologies that we find in Alumotor. So in the light of these market conditions, we see Alumotor to be a really good fit, really good market fit. Its technology value drivers are that it is rare earth-free design with winding made of aluminium rather than copper. And this winding structure is made as hairpin, which is, again, cost-effective, simple to process, and simple to take apart. Such design is naturally lower in cost than a conventional permanent magnet machine and is designed automatically, you could say, even with the security of the supply chain in mind, as well as end-of-life impact due to simpler disassembly and less environmentally hazardous material content. So our analysis has further identified a potentially obtainable market of 1.5 million units by 2035, and this is annually, within the light-duty sector. Potential targeted customers could be OEMs, OEMs who currently have no permanent magnet solution or have no supplier that is ready to take them on the journey without permanent magnets. Within the off-highway sector, obtainable market there, we have identified 1,000 units in the mining and the airport vehicle sector annually by 2035. And again, similar profile of the customers would be the ones, OEMs, seeking to electrify their portfolio and reduce their environmental impact. So worth noting here, you'll probably spot the difference, 1.5 versus 1,000 units, so the volumes at two ends of the spectrum. And the reason we are highlighting this is because the Alumotor and the cost effectiveness of its supply chain and manufacturing process works in both of these scenarios, low and high volumes. So supply chain that we have designed for Alumotor has all the important characteristics of a sustainable supply chain. Firstly, It minimizes the negative environmental impact by utilizing aluminium rather than copper, aluminium being one of the most environmentally friendly metals. There is no extraction of copper, there is no extraction of rare earth needed to manufacture this electric machine. And mining of both of these metals is associated with harmful and hazardous impact to the environment. Secondly, second characteristics of a sustainable supply chain is that it conserves energy and its natural resources. We have calculated that approximately 8% reduction in CO2 emissions can be achieved through this supply chain versus a supply chain that manufactures copper windings. And the preservation of natural resources again comes almost naturally because aluminium within one product, there are even bold claims, can be infinitely recycled. And finally, the final hallmark of a sustainable supply chain is that we have designed it to be economically sound manufacturing process. It is cost-effective in low and high volumes. It is readily manufacturable in this country, and it is independent from geopolitical tensions. So what is that cost benefit that we have achieved? It is approximately 40%, 41% based on the cost of material, raw material only. So what we see here is based on price per kilogram of raw material. And raw material here is permanent magnet, rare earth, copper, and aluminium. And the prices here, the figures here should not be confused with prices of the electric machine. This is purely based on price per kilogram of raw material. And Ricardo is uniquely positioned to deliver the design and the build of low-volume scenario. And through its production, through its end-of-end capability in design, build, and test, we would make an ideal partner for low-volume production. Having said all this, a sustainable supply chain, of course, needs to be enabled by the quality of the product. And Alumotor is it. Alumotor delivers performance. Through a recently completed design validation program at Ricardo's test laboratories, just down the road here at Leamington Spa, we have demonstrated that the performance of this machine is comparable to the performance of the permanent magnet machine, the one that's considered today as being a workhorse of electric powertrain, and the one dominating most electric vehicles that we see on the market and on the road today. So aluminium hairpin, permanent magnet-free rotor with innovative cooling technology offers increased operating efficiency in this topology, synchronous reluctance topology, while drastically reducing material cost. And to summarize, the key benefits of this machine are secure, sustainable supply chain, significant cost reduction, flexibility to balance cost versus performance, ability to scale to a variety of applications, a robust and durable design, unique set of technologies within one product, are designed for low end-of-life impact, and most importantly, readily manufacturable in UK. Thank you.
Thank you very much. That was really interesting. We'd like to take a seat, and then we'll have our next speaker, Aaron, up, and we can hear from you. Thank you.
Thank you, Dragisa, for kind of introducing us to some of the challenges around sort of supply chain security and manufacturing a product. What I'm going to talk to us today about is supply chain security around a fuel, and so namely how hydrogen can bring us sort of a clean alternative to imported diesel, one that we can manufacture here in the UK, but also how with this new emerging supply chain, some of the challenges that come with it around really needing digital integration in modeling. So I'm Aaron Bates, CEO and co-founder of Hydrologic. We're a company that builds solutions, both software and hardware, to help hydrogen operators operate those businesses that they're building, whether that's on the fuel, transport, and delivery side, or indeed the use of hydrogen-powered machinery. We've started looking at really the first space of being off-grid machinery, so some of the types of machines that Dragisio was talking about here. Things like generators, excavators, used in construction, festival events, TV production. And before I kind of get down into sort of some of the elements about a project we did with the Digital Catapult and looking at how this digital integration works, it's kind of helpful to kind of set a bit of some of the scene around the supply chain that's emerging. So firstly, diesel machinery is an absolutely huge polluter. It produces 2.6% of our global carbon emissions. People don't realize that because it's hidden in a field. It's behind hoarding in a construction site here in London. But even in the UK, there's an estimated 951,000 of these machines. And if we kind of step back and look at a global level, if we just looked at one asset class of generators, there's 82.6 million of those units out there. And today, they're predominantly run on diesel, right? And we'll come on to a little bit why, but where is that going? Well, really, the fuel that is seen as the replacement fuel, the end goal fuel, is hydrogen. And why? Well, it's because hydrogen will be both the best choice environmentally, in terms of low carbon, no local air pollution, no noise, but crucially, it's becoming an economic choice as well. Now, for what it's worth, hydrogen is not economically viable, really, today, but with the pricing that's coming into the market around 2027, 2028, so we're talking £10 to £12 a kilogram delivered to a site, it does bring it down to cost equivalence with diesel in these off-grid machines. So it's becoming that economic choice as well, and as I mentioned already, because we can produce it in the UK, you can produce it locally from solar or wind, you can sort of get a bit of geopolitical independence as well. Now, in terms of the industries and machines that are already starting to move this way, if we look on the right, those industries share kind of four really common characteristics. Firstly, they're off-grid, so we can't plug into the grid to use them. Secondly, they're high energy utilization, then high asset demand, and temporary. So none of those things really lend themselves well, and they're often in space-constrained places as well, to using on-site solar along with batteries. So we need a fuel, and that's why today they've been using diesel, but with a lot of pressures coming from a lot of different reasons, won't drive into why we're driving towards hydrogen, but they are shifting, and they're setting their policies and their ambitions towards 2030 around diesel-free sites and moving to hydrogen. Now, in terms of the machines and asset classes going there, really the industry is starting with generators, and it's for the reason that they are the literal workhorse powering those industries, but also that kind of first stepping stone to a lot of these other asset classes. Now, most OEMs are going out and building or battery and hydrogen machines. And in both cases, the hydrogen generator unlocks those. So in a hydrogen-fueled machine, it's quite an easy step to do user refueler, bring the hydrogen to site, you're putting it into a generator, it's easy enough to put it then into a mobile fuel pump and refill machines on site. And we've done that today already, so that's not a big step. But equally, if you're going to a battery machine, what did we say? Well, we said they're off-grid, right? They're going to need to recharge it. They're not going to do that on diesel. So again, it's driving this sort of growth of the hydrogen generator market. So we've got industries, we've got machines, and now the supply chain's emerging. And so there's four big kind of, simplify it, four big blocks of that supply chain on the fuel side and on the end user side. So the industry's going, the machines are going, the supply chain's coming along, but using it's really hard, right? It's hard for those fuel suppliers, it's hard for those end operators. And it's hard because there's a big gap in knowledge and capability. It's hard because that supply chain is complex, disconnected, there's a lack of standards. In short, a lot of it's new. And this is making it hard not just for adoption, but scaling. And that scaling point's really important. And so with that kind of context, with the project we ran with Digital Catapult, it was really to look at that central challenge, right, around this disconnected new supply chain that was going to need to work at scale. And so while there was four big stages, there is a fifth layer in the sense that the OEMs, the machines coming into this market. And so this was a bit of a mapping we did of all of those different interfaces, those different connections. And at each one of those points, sorry if it's a bit small, but those red circles, you have not only a data interface, an information interface, you've got a contractual interface, you know, an operational one, product flows, financial flows, right? And at the moment, this supply chain as it's emerging is doing everything via phone call. Now that's not going to work at scale, right? If we want this supply chain to really work, we need a digital first supply chain to handle this complexity. And it's sort of where kind of we got a bit of a motto that, you know, the industry needs API calls, not phone calls for this to work. And with that in mind, that's where we set forth with the Digital Catapult and the project on the digital test beds to try and solve this and drive kind of 3 big benefit areas here, sort of unlocks. And the first was around enabling innovators to digitally test their innovations before going out and building them. So be that a physical product around the specifications, or a business model about how they might work and contract, who they would work with. What is their costs going to look like? Through to how does the supply chain get structured? So that was one of those key aims that we were able to actually succeed on as well. And the next was around that kind of supply chain connectivity and looking at the data in that. And, you know, data connectivity through this, yes, it's going to deliver some of those kind of obvious things around, you know, faster product time getting it through the supply chain to market, or it might allow preventative maintenance at certain places. But what I think was really interesting that it highlighted is that actually it can unlock, reduce risk and liabilities through the supply chain. It can make contracting easier and meshing of how different parties have to contract and work. And yeah, there was sort of part of that was fuel tracing around purities, carbon footprints, you know, pressures, where is it coming from? So all of this information is really crucial for the operations of it. And the third one was that there's very few physical supply chains that have emerged or been built since kind of the advent and proliferation of digital technology. Most supply chains have had to go through a digitalization process where they take their paper-based processes and work out how do we do this digitally. And we really saw that actually with the hydrogen supply chain as it's emerging now, it's got this wonderful opportunity to leapfrog that, to be digital first. And so one of the objectives was to see, could we build a bit of a blueprint for how this digitally integrated supply chain might look? So with those aims, we set out and we ended up building what we've called Forerunner. It's a digital twin of the hydrogen supply chain. And so it captures technical product specifications as well as kind of company and commercial relationships, so that you have a digital twin built for the hydrogen industry first, and built with the fact that there are a lot of unknowns coming. We don't know every which way that this is going to go, and so therefore the graph database and the ontologies needed to be extensible to account for unknowns yet to be encountered. But similarly, we can't begin to imagine all the ways that someone's going to want to analyze a digital twin of something, right? So it sort of is foolhardy to think you're going to be able to build the application on top that's going to meet everyone's needs. So actually it was really crucial to make sure we built a very easy to use API that other people could build on top of. Now, in order to kind of show how that worked, we built out the kind of a first reference application. Let's say, look, this is what it could do. This is how you could use it. And that was a supply chain optimization tool. It was there to showcase the ability to model technical details within a supply chain as with relationships. Now, in short, what it would do is you'd pick a point on a map and say, hey, I want, 15 kilograms of hydrogen there, or maybe 300. And then it would pull back, it would analyze the digital twin, it would pull back the data that we'd pulled into that from other real-world projects we've been doing, as well as some through the project. And it would tell you, well, okay, for that location, this is the type of storage tanks you're going to need. It's going to be produced by this producer and transported by that one, or sort of stored by this one and transported by that one. 3 independent providers. Or maybe it's actually a linked set of services all from one company. So it's starting to model out technical specifications. Do you want bundles of cylinders? Do you want a 40-foot trailer? What's going to be best for that site? What's the breakdown of carbon for each step of the chain? What's the cost for each step of the chain? What percentage of that supply location are you using? And, is the purpose of it was to show what's possible and to help other people realize how they could go build on top of it. So in that, showing that other people would build, Hurus Energy, they've come and built a series of total cost of ownership models, both for hydrogen producers as well as end users. So in terms of kind of like wrapping up, what's next? Well, look, the digital twin there, so our whole company is about making operations easier and more efficient, so we're looking at how we actually help build this into our own products, our Hydrologic OS, to make that smarter. But similarly, as we go out and do projects, do hydrogen deployments of these assets, and we've done 20 hydrogen deployment projects in the UK already, we keep enhancing that model and adding data in. And, you know, look, open to new users, yes, the project and the program with Digital Catapult's finished now, but we're going to keep running this, right? And the point of this was to help the industry scale and grow faster. And that's the point of the company we've set up, to drive change quicker, to drive decarbonization quicker. So we're going to keep running this. If anyone thinks it could be useful, please do come talk to me. Similarly, if you're just interested to understand more about hydrogen and hydrogen operations, I'm on LinkedIn. That QR code will take you to more information about the API and the hydrogen testbed. And thank you very much for your time.
Thanks, Aaron. Interesting stuff there. Thank you very much. Like I said, take questions at the end if that's okay. And then, Chris, would you like to come up? Thank you.
Okay. First thing you notice is no picture of me, and that's because I didn't want to frighten anybody. The second thing to say, I'm going to talk about welding, so I don't want to frighten anybody about that. So this is just to present a little bit about two Innovate UK funded projects that Cambridge Vacuum Engineering have been involved in. So Cambridge Vacuum Engineering are a company in Cambridge that do vacuum engineering. But what we do is manufacture welding equipment using electron beam technology and laser beam technology. We used to make vacuum furnaces, but we no longer do that. So what we're going to talk about today, and my colleague Max is in the audience, so if you've got any difficult questions, ask him. The other questions I'll pass on to the panel. So what we're going to talk about is two projects, EB BAT, which is about welding battery, joining busbars to batteries, and EB eDrive, which is about stators for electric motors. We'd like to acknowledge all the staff at CVE, people at TWI, Colin Ribton and Vitaly Jefimov, Innovate UK for providing the funding, part of the funding, also staff at Cosworth, Graham Martin and Vasu, and for the Stator projects, Bill Dunn and Dimitrios. So starting off with what are the drivers for these processes, you might think, why do we want to weld bits of electric vehicles? And why do we want to do it in a fancy vacuum system? And we'll talk about the reasons behind that, but also what we've done and where the projects have got to now in terms of commercialisation. Oops. So starting with the motor, so electric vehicles have all got a motor, which comprises of a rotor and a stator. In this case, you've already heard about the aluminium version, and one of the things about the electron beam process is it's pretty agnostic to what you weld. So we can weld copper, aluminium. Nobody's made a tungsten rotor yet for obvious reasons, but that kind of thing. And hairpins are the trend towards maximising the current density you can get in a stator by using rectangular section wire rather than round section wire. These are insulated. You can see the insulation on the wires. And just to point out that Cambridge Vacuum Engineering has been welding turbochargers for about 40 years now. So every vehicle with a turbocharged engine in it will have an electron beam welded rotor, which comprises an unweldable nickel alloy and a steel shaft. They make millions every year. And so we have an experience of the automotive industry. One of the experiences is it has to be cheap, it has to be fast, and it has to be reliable. So that's our drivers for that element. And one of the traditions currently is that these are welded using a laser. And I don't know if you're familiar with laser welding, but one of the materials used to make laser mirrors is copper. So you aim your laser at a piece of copper, what it does is bounces back and either destroys a laser or burns a hole in the roof. We've actually seen both. But it works pretty well, and most of the electric vehicles around have got a laser welded stator. But electron beam welding overcomes many of these issues, and in particular the reflectivity one. Also, you need to have some shielding gas. If you melt copper in air, you end up with an oxidized product, and that reduces its conductivity, it reduces its strength, and ultimately makes a motor that's not as good as one that doesn't have those things. So the electron beam process is produced in a vacuum. A vacuum is a really good welding atmosphere. It eliminates the oxidation, and it provides a really good way of vacuum degassing the weld metal. Oops. Hang on. So what you see here is the cross section through a welded hairpin. It's actually a work of art. It's a beautiful columnar crystal structure. What you notice is there's no porosity in it. If you do the same in a laser weld, you'll find there's spherical porosity. That reduces the cross-section. It actually reduces the conductivity because of the oxygen in the copper. In these cases, we're welding oxygen-free copper. But what we've also shown is you can weld, which is quite an expensive grade of copper because it's oxygen-free. If you weld what's called ETP copper, electrolytic tough pitch, it has a much higher oxygen content and is very badly quality controlled. Probably apologies if there's any copper producers in the audience, but it's a sort of pretty rough version of copper wire. And what we found is welding in vacuum, you can actually achieve very similar results with little porosity. And you also notice the cutback of the insulation here is quite short. So with a laser welded product, you need to cut back more insulation, and that means the legs are longer. And it's incredible how 3 millimeters of copper wire built, it adds up. If you snip it off, then you have a bucket full of copper wire pins. You chuck them out, or there's a recycling guy on. And so what you see, we can reduce the cutback. We don't worry about how closely the parts fit. And just to show you the strength difference with the laser products, it's 200 newtons. If you do a pull test, the electron beam product is 1200 newtons. And actually, you don't really need to worry too much about the strength of the bond, because if it gets to 1200 newtons, something else has gone wrong. So, but what we found is that it's a very repeatable process, and it lends itself to high volume production because of repeatability. And what you can't really see here, but this is an X-ray showing the integrity of the product. So in terms of industrialisation, we've now got to a point where Ford UK and other parts of Ford are looking at this as a process to develop and use in production. And currently at CVE we have a machine which has been built, is ready for primary production, but what we really need is to engage with a complete production facility. But it's gone from the Innovate UK development test to a near market opportunity. So you see the advantage is the cutback along the beautiful little pins, and what we've said is the 100 milliseconds per weld. So if you work that out, it's 194 pins in a stator. For anyone good at maths, you can tell you how long that's going to take. So that's a stator situation. So we got to a point from early development. We're now looking at other materials. We're looking at other insulating materials, and we're looking at other OEMs who'd like to use this product. And certainly, I think you've shown the range of applications, and it's massive. It's a huge market. Until we start using hydrogen for everything, when we might have to worry about it. So in addition to in an electric vehicle, the way you get the electricity stored is in the battery. This is a Tesla example, so it's got 3,000 batteries in it, and they use wire bonding, so they end up with 4 bonds per battery per cell, buzz bar. So you're looking at 12,000 welds per vehicle, and it's nice to build in a bit of redundancy, because what you don't want to do is one weld snaps and you're stuck on the M6 saying, damn, I wish I had a hydrogen car. But actually integrity is the critical thing. It's great to make things really quickly, but if you do it quickly and badly, then that leaves you into some other issues. And in particular, there's some applications which involve flying electric motors with batteries, and you don't want to be halfway across St Paul's Cathedral when your battery connection snaps. So one of the things we've realised is that when you're welding, nominally you use a continuous power, and what we found with that though is if you go too fast you get lumps and bumps, and it also introduces all the energy at once into a battery, and what you don't want to do is fry your battery. So within this EB-BAT project with TWI and CVE, we've developed a very fast beam deflection system which allows you to make spots on the batteries, and that looks like only a tiny spot, but if you do all the spots in different parts of the battery module at the same time. So one of the huge benefits of electron beams is they're deflected by electromagnetic fields, and it's quite difficult to get lasers to move at the same sort of speed. So here we're looking at 10,000 meters a second, 10 kilometers a second of a deflection speed. So it means you can weld an array of 60 cells very, very quickly. And in a way, that's the benefit from a point of view of productivity. And what we're able to do is deflect the beam over a complete module of batteries, weld them all at once, but do it in spots so that the heat input into each battery doesn't fry the anode or the ingredients inside it. And they are quite sensitive to being over temperature. So what we're also looking at is different materials. We've looked at aluminium to copper, steel to copper, steel to aluminium. And one of the things about the steel and copper buzz bars is that traditionally they're nickel plated to make the laser process work. And if you get rid of the nickel plating, saw the graph of nickels up there on the stuff you don't want to throw away. And so avoiding nickel plating, making the welding successful. And this means that we're in a situation where we can make all of these little spot welds in one go. So that you make a spot here, you go over there, make another spot. But it happens at 10 kilometers a second, so you don't really notice, it just goes bzzz. And I don't know how to make the video work, but how does that work? Can you click on the video? Okay, well, we can show you later on. Yeah. So basically, what you'll see is that the beam moves very, very quickly from cell to cell, makes a spot, and then eventually you'll get a continuous ring of spots, and that gives you exactly what we need. This is aluminium to copper. You think metallurgically that's not a great combination, but you could make 14% of aluminium and copper, and it makes a really good alloy. So if you get that right, you get really good microstructure and properties. This is nickel-plated copper to steel. So what's happening is people are changing the battery can materials, changing the buzz bar materials, and they're becoming more difficult to weld. Welding steel to copper is probably one of the worst things you can do in life. So we've done some mechanical testing because you need a good strong bond. It has to deal with fatigue performance. And this is the first EB battery pack that was produced at TWI as a demonstrator. The astute people in the audience will know it's a dead short from the cap. So you don't want an aluminium box to put it in because that would short out the batteries. So at the moment in EB-BAT we've got more development work going on. It's reaching the end of the Innovate UK programme, but we have a continuation programme, and we've built a machine for anybody who wants to come and test battery or stator welding. And it can do quite big pieces and big modules as well. So if you want to come to Cambridge Vacuum Engineering and have a go, you're all very welcome. And in terms of e-drive, we've got EB welding's been demonstrated. It actually works really well. And the process has got to a point now where it's ready for industrial exploitation. We've got very high quality, no porosity and high strength. And we've got the possibility for a wider tolerance to gaps. And we can do in-process QA, so you don't need to necessarily test it until you're happy with it leaving the chamber. So thanks very much. That's all I've about to say. And if anybody would like to see the video, we can show it later.
Yeah, thank you. Let's see if we can get the video going in the next 10 minutes. No chance. Okay, apparently no video. So thank you all very much for giving those interesting talks. I'll open it out to any questions in the audience. Hands up, there's a roving mic. We've got one over here.
Hi, it's just a question about...
name and...
I'm Seb Leaper, I'm the co-founder and CEO of Water Cycle Technologies, and we recycle lithium batteries. So kind of interested in your presentation in particular. It was about, have you done any calculations on potential weight reductions by being able to remove the nickel plating? And also, what's the downside to the electron beam in terms of cost compared to laser processes?
Yeah, so I think three very good questions there. So in terms of the efficiency, in terms of cost, so the cost of electron beam welding equipment is normally similar to that of a laser, but the through life costs are significantly lower. So the electron beam machine is nominally at 90% energy efficient in terms of wall plug electricity. Lasers getting better all the time. They're probably up to 30 or 40% now. Every time you buy a laser, you have to buy a big fridge with it, so, or a little fridge. You also need process gas. So one of the things that we always emphasise is vacuum is really cheap. It's just a pump, and you don't need. All you need to do is have wall plug electricity, and you don't need any additional gases which disappear, and you don't really recover. In terms of there's always this concern, people say, oh, it's a vacuum, that'll take ages. Actually doesn't. So a typical turbocharger weld cycle is, for the whole evacuation and welding, is less than 7 seconds. And for a stator, we can calculate it, we can weld one, including the pumping time, in 31 seconds. So you've got 194 welds in 31 seconds. So, and process time is pretty quick. And it's also immediately available to assemble in the machine. So there's no other stuff you need to do to it. Sorry, I can't remember what the third question was. Yeah, so the plating is very, very thin, but it's a cost, and it's a cost to apply it. So if you can avoid it, and ultimately these things are put inside a box, which is environmentally controlled, so you don't need to worry about the corrosion protection that nickel affords, and it's mainly there as a coupling agent for the laser process. I don't know if everyone agrees with that, John. So yeah, I mean, recycling is also a really big thing that we'll be looking at, and one of the things you can do readily with the electron beam is melt metal and in a vacuum. So you can actually refine and melt stuff. And one of the examples we have is for tantalum capacitors. When you assemble a printed circuit board, you cut the legs off, and you end up with a big bag of legs. And the big bag of legs is low value because you don't know what the composition of each leg is. So if you melt it into an ingot, and then you can assay it, and you can also deoxygenate it. So you end up with a much higher value product just by putting it in a box, pumping it down and melting it.
Interesting, thank you. Does that answer your question? Yeah. Another question just behind that gentleman. And again, name and organisation, please.
Len Pannett, Supercharged 3D. All three of you have got some fantastic innovations, and I can see absolute applications for both. I'd also love to find out some of the skeletons about what makes your thing not so great and why we're not doing 10 times more. A few years ago, one very noted industrialist said that if you compare the UK to other leading economies, the UK generally has a reticence for innovation, not developing innovation, for adopting it. Has that been your experience, and what have you done to mitigate that risk or combat it if you have come across it?
Interesting. Reticent to innovation.
I think you're absolutely right, that we've experienced exactly that. You come up with this amazing technology that, so on paper, so we've also done a lot of offshore wind work, and on paper, the cost of a machine is recovered in about 3 weeks. And you think, well, why doesn't everyone go and buy one? And it's a natural conservatism that say we've been doing this for years, and this works really well. The other element, which is a bit more cynical, is people sell time. So if it takes you 300 hours to make a welded structure, you get paid 300 hours at £50 an hour, that's a deal. If somebody comes along and says, you can do that in 20 minutes, you go, what can we do with all these people? So we're not trying to put people out of business. I think we're trying to, these processes are much more handleable, much more attractive to the younger generation. If you say to somebody, do you want to be a welder? You think, that's joking. But if you want to be an electron beam welder, you have a PlayStation controller and a mouse. Anyway, I like welding.
Yeah, I guess in the space we're in, where a lot of our end users and customers are in, say, the construction industry, for example, or potentially on the opposite side on, hydrogen fuel supply. Now, by nature, hydrogen fuel supply, people are pretty open for innovation, so there's not been as much of a challenge there, let's say, from the new entrants. I think a lot of the incumbents in the space have gotten very used to hydrogen being a specialty gas, which they make a really big margin on, so they are reticent to new innovation in that space, for sure. But I would say that we've not found a big reticence to innovation, actually, surprisingly. So you'd think construction, God, they don't want to change, so I've always done it this way. But actually, because it's such a small, thin margin industry, they are always looking for what is the next thing that might get me that edge. Now, yes, okay, hydrogen adoption hasn't really taken off because today it's 3 to 5 times the price of them using diesel, but they know that the changes they need to hit by 2030 to get a diesel-free site for national highways means they, in order to contract for that, they then need to be contracting in 2028. In order to win the contract, they need to show they need to do it earlier. So they're actually, I've been, let's say, pleasantly surprised at how willing we are. But I think your point around services is a good one. Generally in the UK, we're an economy that shifted to, well, be the service provider for the world. Well, service providers don't really like reducing bums on seats and hours sold. So I think there is a wider challenge with that of how do we get back to remembering that what's really scalable, well, a product, because you only build a product when someone needs to do it over and over and over and over again. When someone asks for something once, that's when you sell them a service. Surely as an economy, we want to sell something that people want to buy again and again and again, not once. So I think there is a wider challenge for sure.
Thank you. It's a really interesting question, and I think I can answer it partially, purely from my professional experience. So I've been working in this field of R&D and commercial projects for many years, if not decades. I think there's a lot of innovation in this country, lots of ideas. It is when we hit the economy of scale, this is where they kind of halt. Why that is, it's going to be a perpetual question. In my view, perhaps lack of investment in that scale up might be halting the inspiration for the innovators to go to that next level. But certainly, this is a very big gap that is easily fillable through strategic investing. Perhaps, who knows?
Thank you. Another question over here.
Yeah, hi, Tim Lawrence from Digital Catapult. I'm really interested in the aluminium motor idea and the concept and how it works, but is it possible to have a full UK supply chain in that end-to-end? I mean, aluminium I know comes from different parts of the world and that sort of stuff, but how much have you looked at that? How much of the supply chain can be, you know, one of the things you talked about was the benefit of having a more captive supply chain in the UK. How much of it can be really captive, yeah? Do you think, from what you've seen so far?
So perhaps going to the level of how much it is captive can be the topic of our next study. We focused on the availability of components, so that the aluminium hairpin, the wire itself, is readily available to purchase in this country. It's readily usable already in other products. So in mainstream product for that wire is the big transformer. So this is the scope through which we've looked at. Obviously, there's a steel manufacture that at some point was happening in this country. Might in future, who knows? But it's not impossible.
So I'd like to add to that, which is so. When we think about new supply chains, I think it's really important that we don't try in the UK to capture too much of it. I think that there's places that it makes a lot of sense and there's a lot of value add in doing and that we're very good at and we could be very good at. But I think thinking into too much in terms of isolationist in the UK is maybe the wrong way. We obviously need to have friendly supply chains. We need to, and if you were here in the room before, I wasn't, but I'm sure Martin was talking a lot about friendly supply chains in the climate talk. But I think it's really important we tap into that global supply chain, because if you think about some of our biggest successes, I mean, aerospace, we're exporting, 85% of the aeroplane, 90% of the aeroplane engines we're producing are exported, and diesel motors, again, it's a similar figure from the JLR factories. I mean, so there's a lot of export opportunity as well as, and so we are part of a global supply chain. So I think we need to always keep that in mind. Any final question? I think we've probably got, Arben, we've got a minute left, 2 minutes left? Time now. Okay, one final question if anyone's got it. Otherwise, we will thank our fantastic... Okay, yeah. Thank you all very much for joining us. The sessions continue, so we've got a few more sessions in this room and in the other rooms, and do stay for drinks right at the very end as well. So thank you very much for everyone.
This is a session on future of supply chains for the UK, and in the panel today we have Alok Chowdhury, who's the Professor of Supply Chain from Warwick University. Should I let them each just say a word, or do I just introduce everyone and panel? And then we have Aaron Bates, who's the CEO of Hydrologic, which is a turnkey solution to replace diesel for off-road devices. Then we have Sophie Walker, who is the head of strategic partnership from Open Data Manchester. And we have Howard Ruprecht, who's the managing director of CS Connected, which are a cluster of semiconductor compounds in Wales, which he can explain further what he does when we come to the questions. So the session, as we are mentioning, is to look at the UK supply chain and the innovations that can support them. So the first question I'm posing to the whole panel is, what do you see the future of the supply chain you're involved in the next 5 years? Alec, if you would like to start.
So I think the future of supply chain is pretty much driven by what happened over the last few years and what we see currently in the market. The first and foremost that is coming to my mind is, which is driving supply chain, is the strict regulatory requirements. So let's talk about the pharmaceutical industry, for example. Again, there are a lot of regulations that is coming up. Auto industry is currently, if you talk to auto industry and the managers in the auto industry, quite a lot is kind of driven by UFPLA and all that. All this is all talking about is that have that visibility of your supply chain, how you can map your supply chain, how you can risk sense from your supply chain. So first and foremost, it's about, driven by regulations, driven by compliances, and also other set of sustainability requirements, ESG compliance and so on and so forth. So understanding your supply chain to know where your supply chain actually is, like, where your suppliers, their suppliers, and so on and so forth. It's a massive task. It's a massive task in itself. And in order to, you cannot just rely on the manual way of doing it. So quite a lot is happening around AI-driven supply chain mapping, digitally enabled supply chain mapping, some use of blockchain, and so on and so forth. So that is gonna accelerate over the next few years. If you looked at the role of AI, particularly to risk sense coming from any part of the world, that is gonna again drive the next few years. What we see happening in the US at the moment, that is gonna drive the trade regulations, because if your trade regulations and the policy changes, you need to change the network, you need to redesign your network. So a lot of what-if scenarios that can be developed with upcoming regulations and the impact it may have on the supply chain. I think that's a few points to start with, I would say. With you.
Aaron, about the new supply chains?
Yeah, new supply chains. Well, I mean, I suppose we're in the business of hydrogen. That in itself is a pretty new supply chain. So I think if next 5 years, I think next 2 years is probably a lot of the fuel suppliers getting geared up, a lot of the transporter companies getting themselves adopting the right assets. So a lot of the foundations put in place over the next 2 years, and then the kind of 3 years in, then after that, it's where they really start getting used to operational scale. In the last session, we were talking a bit about how it's one of the few industries which has the chance to be digital first. It doesn't need to go through transforming paper to digital, and I think so really the next year to 2 years is also really helping a lot of those companies embed a digital first mindset about how they integrate the supply chain and how it works, so that it can work at scale, because compressed gas hydrogen is fundamentally harder to work with than diesel, where you can just pour some more in a bucket and throw it in your generator. So I think for us, next 5 years it's just establish and then get used to working at scale, because within 5 years the thing needs to be working at scale if we hope to meet decarbonisation targets.
Thank you very much. And Sophie, about sustainable supply chain view.
Sure. I think I would really echo everything that Alex said already, which is that there's such a big drive for regulations, and it's really pushing a lot of people to think about how to do things differently. I can't see that getting any easier or going away over the next 5 years, even with the stuff that's happening in the States. I think there's a lot happening in Europe around this, and for that to work, unsurprisingly, I'm going to talk about data. If anybody knows me, they know this is what I'm banging on about all the time. But I think that to meet those regulations, it's really important that people have systems in place that help them to gather the data right from the get-go, because at the moment a lot of that sustainability reporting is being done as an afterthought and a kind of add-on at the end. And it's, I think, hopefully I'm hopeful that what we will see in the next 5 years is people actually embedding that kind of data capture and sharing right from the start, and that being a byproduct of the manufacturing process and of the kind of supply chains. And it's really exciting to hear about the fact that might happen in hydrogen, because they're not having to kind of change all of their systems, but it's a brand new supply chain, and how could they maybe actually take the lead on that and do that in a really new and exciting way. So I think there's so much volatility, and having the good data so that you actually can see your supply chains and understand them, like Alec was talking about, really kind of will help people to navigate what is going to be a volatile and kind of fluctuating situation. Because if you don't know what your supply chains are and where things are coming from, how can you kind of prepare for doing anything different or understand where your risks are? So I think hopefully that's all going to, I think in this challenging climate, I'm hoping that there's going to be those kind of changes that come about that really help people to deal with the challenges.
Thank you very much. And Howard, about supply chain clusters.
Thank you. So, my focus is on the semiconductor industry, and I think to talk about the next 5 years, we probably should start about talking about the last 5 years. So probably all of you will remember at the beginning of the pandemic, trying to buy a car was darn near impossible. And that was because of a relatively minor disruption in the semiconductor supply chain, which is truly, truly global in its size. And, really, when we start looking at that supply chain, And what happened, there was a lot of calls to try and say, well, we have to have our own sovereign supply chain. But actually, that's an illusion. There's no way you're going to have a sovereign supply chain in the semiconductor industry. It doesn't exist, and no one country has the capability to make that happen. So really what you get down to is having a sovereign capability that you can trade and still play in that particular game. And that's something in the UK we do very well in certain areas, compound semiconductors being one of them. So I think what you will see, though, is some contraction of the supply chain across regions to increase resilience going forward. So, let me give you an example. I'm sure most of you have got face recognition on your phones. Probably most of you don't know that that chip started life in South Wales in a company called IQE. And then it probably did about 14,000 air miles before it ended up back in your hands, going to various different suppliers in Asia and all over the world. Now, that's consumer electronics, but if you take something like the automotive industry that's incredibly important for the UK, there is desires to contract that supply chain. You could probably do a lot of that within Europe. But what I do see is that, people are only just waking up to understanding that supply chain. So the car companies are finally realizing that, oh God, with electric cars, I've got to buy semiconductors and I don't really understand them. And the semiconductor people don't really understand the automotive supply chain in quite the same way. And so even though we're making compound semiconductors in Wales and building cars in the Midlands, those two things are not as well connected as they could be. And there's really good opportunities to make those supply chains smaller and more resilient.
Thank you so much. Interesting. For the next question, what do you think of how quickly do you think digital technologies are being adopted by the industry, and what's holding the adoption back? Who wants to go first?
I can jump in on that. I think one of the challenges that I've seen with kind of companies, not just in the UK, but certainly in the UK, adopting new technologies is that I think there's a bit of a risk aversion, and people are nervous about it. There's a lot of people wanting to see that it's become the thing, and then they'll adopt it along with everybody else, but that's just really, it means nothing ever gets adopted, especially if you're a small business trying to keep going in that space. If everyone's just telling you come back in a year when everyone else is doing it, there's only so long you can last on that. So I think that's a real challenge, and I haven't worked out how to kind of overcome that in any kind of meaningful way, if I'm honest, other than trying to talk to everybody and try to get everyone on side, which is also very time consuming. But I think there is a lot of really amazing innovations happening here, right? And lots of things that can really help people, and I think it's about maybe helping more businesses realise that it isn't a huge risk for them to take. I think there's also a big skills gap is the other thing I've really noticed, especially from a data point of view, is people really don't understand data. They, almost anyone we've spoken to over the last 3.5 years really don't have a clue. And then that's okay. But then, let's actually put some effort into skilling people up and think about how that can really help us to accelerate innovation, but also put us as leaders in the world, I think, in terms of how we do this thing across our supply chains, because we're certainly not completely sovereign on lots of these things, and how can we work with our partners in other places and show them more interesting ways of doing things. But yeah.
Thank you.
So I think you asked about digital technology adoption.
Yes.
Semiconductors are a fundamental enabler for new technologies. And so when I look at digital technology adoption, the technology definitely has to be ready, but that's not normally the gating factor that drives the adoption. It tends to be political or economic or other reasons that would do that. What I would say is there's some really interesting things happening in the world, particularly around quantum and things like that. Now, recognize that you're not going to be able to do any of those things without compound semiconductors, driving photonics and other technologies that will allow these things to happen. So we really look at it as being an enabling technology and having the ability to scale those things when they're ready to go, and that's something we can still offer.
Yeah, I think sort of a lot of that's been said already, but certainly in the space we're in, we see kind of two bigger barriers, or two big barriers, not bigger, but is sort of part of it's around user experience and understanding how to work with some of those interfaces on the digital technology. And I think there's a huge amount of assumed knowledge around, 3 lines is the menu. And a lot of things, we have it even internally, when we work with some of our sort of software engineers and designers, it's like, well, do we need to use an icon or can we write the words out? And remembering who your user is not always at the same skill level in using a particular technology as you are. And similar on the data front, a lot of people just assume data's going to give me an answer. And you go, well, it depends on how it's structured. It depends how good that data put in was. And I think a skills gap is one of the biggest things. And then second, it's business risk, right? And the time it requires to not only understand the plethora of possible solutions, even in your own space. I think a real big downside of it's very quick and easy to make software and to start a software company is there's far too many, so then how do I know which one to pick? I don't have time to sift through them all. Am I going to make the wrong decision? Well, then I get decision paralysis and I make no decisions. So I think there's a lot of these things which is not a problem of the software, but a problem of how we're helping people find and use the right software.
Yeah. I think just a couple of points on that. I mean, first is, being able to demonstrate the right use case to promote the adoption. I think that's equally important. How you're going to give the confidence to the even company that, well, by doing this, I'm gonna increase my productivity or increase my sustainability or increase the resilience of supply chain. So that's one thing. The second thing is being able to justify the return on investment. So, by adoption, and it automatically will translate to multiple things, and it is going to increase the productivity. But where is that business case and return on investment that can justify that adoption? So I think it needs joining those dots, like, as I said, and also the point that data in itself is not sufficient. How you can meaningfully derive meaningful insights from those data that will then allow you to make those decisions. I think that's equally important. So I think taking all into account, it ultimately comes down to justifying your return on investment, ensuring that you have the right business case and the right use case as well.
Thank you, Alec. There's a question for Howard. How can supply chain clusters like the one in Wales drive competitiveness and digital adoption going forward?
Right. I guess in terms of competitiveness, well, there's a couple of things. I think one of the things we really have to look at is value capture from our innovation. So we've spent 15 years as a country having a strategy of powerhouse of innovation, but our value capture is pretty poor as a country. And you talked about productivity. It's very hard to scale a service economy, actually. So, I look at having more activities, particularly around manufacturing, as ways of capturing value and increasing productivity and growing in the economy. Now, there has to be a good business case for that, but there's fundamentally no reasons why we can't do that, certainly in our industry. And it seems like we have a lot of bankers, a lot of capital, a lot of innovation. Why aren't we capturing more value? I don't mean to sound like Trump talking about bringing it all home, but really there's a lot of things that we just immediately give up on and let somebody else do when we could do very successfully.
Thank you very much. And this is a question for everybody. What should the government's priorities over the next 5 years be when it comes to the UK supply chain and supporting them? Do you want to start from that end?
Yeah, I think the first and foremost is to, again, going back to my very first point, supply chain visibility. Government needs to understand where the supply chain is. Going back to semiconductor example, many of the supply chain managers, they didn't have any clue what the complexity involved in supply chain. Talking about sovereignty, for example, I think no other country in fact, in the semiconductor industry can survive in themselves alone. They can't. No. So there are examples. But talking about the first thing around understanding and gathering those multi-tier data that can give you the understanding of interdependency you have on overseas supply chain, the risk that it poses to your supply chain. So that's the very first, I would say. Second is to focus on going back to learning from COVID. Critical to life products, supply chain sovereignty we talked about, all those things are so important. So thinking from the perspective that how can we ensure that we have got at least inventory for the product, which is critical to life, and ensuring that we have that sort of relationship. Going about sovereignty, again, trade relationship, equally important. I mean, there is a lot going on in terms of trade relationships. So how can we ensure that we have got the partnership with those countries where we are dependent on those critical products and critical to life products? And that also leads to a number of things. For example, supporting companies with this new drive for trade, supporting companies who would like to resort, what incentives that we are providing. And going back to the example, you know, if something that is being produced, we have got a lot of pressure on net zero, for example, in the UK, something that is produced in Far East Asia versus something producing in the UK, you cannot compare them like to like, because if you look at the net zero and the carbon emission associated with it, it's very, very different. So there are areas where government needs to think and support those industries to restore. And last but not least, I think coming back to the conversation we have, digitally powered supply chain, AI has a big role to play here. We can do amazing things with AI and digitally powered supply chain. So how can we incentivize companies and promote the use of digitally powered AI to make some of these things happen?
Thank you. Aaron.
I don't know, speaking only really for the supply chain I know closest at the moment, which is, you know, the hydrogen one, I think sometimes we need maybe just a bit more holistic thinking in a sense that in the UK, we've subsidized the production of hydrogen. Great, we've subsidized half of the market. We've enabled half of the market to do something, but unless someone can afford to buy a machine that's going to consume that hydrogen, nobody's going to buy any hydrogen, right? And so I think sometimes we don't think necessarily enough about the big picture. And, you know, okay, we're talking a supply chain that's making in the UK, selling to the UK, but maybe some of the assets are made by JCB, maybe some of them are imported from, I don't know, France. But, you know, that is one example where I think we can often get very focused in on a topic, supply chain, forgetting that the supply chain needs to supply a customer. Well, who's the customer for this thing? Where's that going? But then on the flip side, I think that a lot of the new supply chains where, frankly, you know, where do we want growth to come from? It's probably not going to come from doing the same things we've always done. We've got to look at what's the new product the UK is going to sell elsewhere. Do we have the right skills to really build out those industries so that we can then be leading in it? And I don't know, sometimes I see enough emphasis on or investment in developing some of those skills and making a decision about which ones we're going after. I think there's sort of like constantly, oh, we're going to do a bit of this, we're going to do a bit of that, and I don't necessarily see us saying no to things, and I think that's maybe a challenge.
So I think building on that kind of holistic picture, for me, from a kind of sustainability point of view, I think what I would really like to see is that, you know, the new government's got this circular economy task force and the circular economy, the Minister for Circular Economy, and I think I would really like to see how we can think about supply chains not as a linear system, but actually thinking about them in a kind of more circular system and thinking about how we can treat our waste as the materials and, you know, kind of valuable resources that they are instead, and bring them back into manufacturing processes and try to see them as something not to be got rid of or you know, offshored, and instead think about how we can actually use them here. So I would like to see a kind of a focus on that sort of more holistic picture around how we think about these things in the whole, and also linked to that, how to make the regulations less of a burden, because I think it's really important that we track these materials, that we understand these supply chains, but it needs to not be a you know, burden. There's so many sustainability professionals that are spending all their time on reporting. How do we get them to do action and not just reporting? And to do that, I think we need the regulations, we need the reporting, but we need it to be much, much more streamlined.
So I think Aaron talked about you know, how you subsidize the supply chain. I mean, I think in the semiconductor industry we're facing a very uneven, unfair world. And if you want to talk about government subsidies, the US CHIPS Act is about 55 billion. Europe is putting similar amounts, and much, much more happening in Asia. The last government proudly announced 1 billion last year, which was so described as flaccid by someone in the industry. So, you know, the success of the British semiconductor industry is in spite of the government rather than because of it. And even the semiconductor strategy that was announced, while it's appreciated, was focused largely on innovation rather than on industry. So what we're really hoping for is, as we move forward, that we start to see efforts to focus on industrial policy that supports manufacturing and particularly supports manufacturing scale-up. Now, if you can support scale-up of our existing industries, it'll give you quick results as well, much more quicker results than playing around with SMEs and startups. You know, you can increase employment very quickly, and you can put the capacity into the supply chains to support British industry and beyond.
Excellent, thank you. I think Howard kind of answered some of the answers for my next question. And one last question, I think we have time. So if there was one area you could address to transform UK supply chain by 2030, what would it be? You want to go from this?
I'll say investment again.
Sure.
But can I just also say 90+% of what we do in South Wales is for export as well.
Nice.
One thing. I think, for me,
Well, it has to be data.
It's about streamlining the regulations. Don't have one regulation that's looking at packaging and a completely different one that's looking at carbon and a completely different one that's about waste. Like, think about how these things are all the same thing, and think about collecting the raw data about the things, and then do all of the analysis that you need to do, like you were saying, right? As in, so rather than expecting people to kind of report the same stuff in a multitude of different ways, let's try to make that easy for people so that we can then focus on doing the stuff.
Thank you.
I suppose a bit like Howard's in terms of investment, but I think, and I can't remember if it was this session or before, but it came up that we're very good at inventing in the UK, but we're not necessarily very good at adopting. And I think we spend too much money on, sorry, for the academics in the room, on base level research. And I think we need to put more of that money into how will this be adopted by the supply chain? How do we make sure that we're taking TRL7 stuff? I don't want to invest in TRL2. TRL7 to 9 and beyond, let's put it there and make it actually do something, because it's only then that you actually realize the value. And I think in the UK we're very good at inventing, not innovating, because innovation requires you to deliver value to someone, but inventing, and then it gets picked up by other markets and they realize the value.
I think just to kind of add on that, it's as an academic, and there are a lot of catapult systems like the one, Digital Supply Chain Hub, and even WMG, which itself is a high-value manufacturing catapult. They do quite a lot of high TRL research, so that's the kind of bridging the gap, sort of. Going back to your question around one thing, I think supply chain resilience is still very, very important. I think where you have dependency on other economies and other countries, that's kind of super important. Question is that how, again, one focus would be around how digital supply chain can help us mitigate risk. When we talk about digital supply chain, I'm talking about AI-powered digital first supply chain. If the government want to focus on, that will then lead to issues around risk sensing, that will lead to your mitigating any risk that comes from the dependency on other part of the world. I think that would be one of the areas that I would focus on, supply chain resilience, but powered by AI, digital twins, and so on.
Excellent. Thank you, everyone.
Can I just add one quick comment to what Aaron said about applied research? I actually spent 10 years working for a European RTO, and Britain is playing a 40-year catch-up versus Europe on applied research. And so, there's not been focus on the higher TRL level research and good partnership with industry. So what's happening in the catapults and Innovate UK has to be magnified and has to continue.
I agree with you.
Thank you so much. I think we have a quick few minutes for questions. Questions? Nemo. Mike, there, Nemo. This gentleman in the cream.
Thank you all for that fascinating panel discussion. Picking up some of the points that you were mentioning there, I'm just going to read this, given we're in an Innovate UK session today. The Innovate UK Catapult Network provides a unique combination of cutting-edge R&D facilities and world-class technical expertise to support UK business innovation. Fully appreciating we've got the head of the digital supply chain sitting just over there. Is it time that we augmented the digital supply chain to be a formal supply chain catapult? My feeling is that what next for supply chain is, could we catch up on what we're supposed to be doing right now, rather than looking at the next big shiny thing?
no comment because I don't know enough about supply chain.
I can comment. I don't know, because supply chain is not a thing, really, right? So can you have a catapult dedicated to supply chain, right? I mean, a supply chain is just a connection of businesses that take something and deliver value to a customer. And so, again, not having thought deeply on this question ever before, but I kind of question, do you need a supply chain catapult, or should we be focused on customers, because that's who buys stuff? And maybe actually it's not about how do we have a supply chain catapult, but do we need export customer group ones? I don't know. So I don't know if we need it or not, but I question whether a monolithic supply chain catapult would be the answer.
Yeah, I actually think you raise a really good point there. And I think the supply chain for, say, our industry is very different to other industries as well. So it's really how you slice and dice the catapults, whether you do it around industry expertise, application expertise, or particular part of it. And I don't think there's a right or wrong answer there.
Yeah, I think that supply chain, I guess, again, don't point any finger on me, is very highly abused word in the last few years. You know, politicians talking about supply chain is just used for anything literally. Like when you are even meaning a company, you're just talking about supply chain. So that's the highly abused word, I would say, over the last, without real understanding of what supply chain actually mean, the dependency it has. It's not just about the customer, it's also about the suppliers, their suppliers, where the location is, whole range of things. And I really appreciate, I truly appreciate the point that you have raised. And I personally feel, yes, there is a need. If you think like one of the things that I am complaining about, like even in the UKRI projects and all that sort of that, in the last 10 years, I have only seen a very few call which is actually addressing around supply chain, and only one call, which are two call potentially. Most of the time it is merged with other things. Only one call I have seen, which was perhaps last year or year before, which was specifically targeting supply chain resilience for textile, for critical minerals, for food industry. That's the only one call I have seen. So I think the meaning of supply chain has got lost a little bit in terms of its overuse in multiple different scenarios by multiple meanings. But we definitely need something like that. I'm not advocating we need a catapult for that, but we need to accelerate research around supply chain. Yeah.
Thank you very much.
I have one more comment about supply chains. Why don't we introduce the word value chain here as well? Because value chain versus the supply chain are two very different things, although they're, I guess, represented in a very similar way. But actually, I think we need to better understand where and how we can capture value in this country. So I'd like to talk about value chains far more than supply chains.
Can I just add to that and say, if we're going to change the term, can we call it a value web, please? Because it's not a chain. It's not a chain, right? They are complex, and the relationships are many to many, and chain oversimplifies it. And I think from a regulations point of view, that's part of where the challenge comes from, is that most of them are designed around, oh, you're just getting this information from another person. No, you're not. You're getting it from hundreds, and they're getting it from hundreds, and it's an exponentially complex system. It's absolutely not linear. So cool. We're all agreed? Value webs from now on. Awesome.
Well, I think changing the name is not going to change the thing. I think, yes, I think the concepts like supply network already exist, which pretty much covers what you are saying, that, the supply web or whatever you want to call it. But it's ultimately that network, that interdependency, the connectedness you have within the different nodes and within different, relationships that you develop. Yeah.
Thank you very much. Any more questions? Do we have time? One more question? No? Thank you very much, everybody. Thank you.
Thank you. So, thank you for joining me, because I realise I sort of stand between some of you and probably making the journey home. And I'm particularly thankful to one of us in the room for at least sticking around long enough, but I'll say that to Janet later on. So thank you for joining me here this afternoon to talk about medicines manufacturing. It's obviously not sort of directly part of the materials and manufacturing bit of Innovate UK, if you like, but
we use a lot of materials, we make a lot of advanced materials, and we use a lot of manufacturing to do it. So you can kind of see the relevance and why we're here. For those of you who don't know me, I'm Mark Talford. I'm Deputy Director of Medicines Manufacturing Programmes in the Healthy Living and Agriculture domain within Innovate UK. So not the net zero domain that's actually hosting us today, but as I said, one of our allied areas. And before we sort of move on to my invited speakers, I was just going to spend a little bit of time just sort of setting the scene for medicines manufacturing within Innovate UK's programmes and kind of how we've got to where we are, and highlight where some of those touch points are really between what we do in medicines manufacturing and some of the technologies and the advances that have been driven through the materials and manufacturing activities that we've been celebrating today. So I'll say a few words of introduction. We'll then have two presentations, one from one of the companies we've supported, Sage Tech, and then one talk more on sort of allied research for medicines manufacturing, actually funded through the Made Smarter programme, and it's always good when I get a chance to see other people's money spent wisely, and we'll hear about that, and then will be an opportunity for questions at the end. So if you do have any questions that arise as we're speaking this afternoon, please hold until the panel session at the end. This slide just sort of gives you a flavour of some of the investments we've made in medicines manufacturing, really only over the last sort of 7 or 8 years, really prior to 2017 and the industrial strategy work that was going on between the medicines manufacturing sector and government that sort of fed into what was the Industrial Strategy Challenge Fund at the time. There wasn't really a lot of targeted funding through Innovate UK for medicines manufacturing. We had an awful lot supporting sort of discovery and development through things like the biomedical catalyst, but it really took industry coming together with government and establishing those challenge programs, and the medicines manufacturing challenge is one of them, to cement medicines manufacturing as an area that Innovate UK wanted to invest in. I'll say a little bit more about how that then led into the programs such as Transforming Medicines Manufacturing, which was Innovate UK core funding and which is going into its final year now, but also how that's led us to work more closely with government and with industry to deliver the Sustainable Medicines Manufacturing Innovation Programme, which we are in the process of ramping up at the moment. So what we've been celebrating here today are some of the Wave 3 Industrial Strategy Challenge Fund programmes. Medicines manufacturing was a Wave 1 Industrial Strategy Challenge Fund programme, which is why it's 2.5 years ago since we celebrated that. But I thought it was interesting just to have a look at what the original business case was and how we structured those investments. And there were some small investments in collaborative R&D programs for industry, but we made some really big investments in infrastructure to support growth in our capability to innovate in medicines manufacturing. So the Medicines Manufacturing Innovation Centre, which is managed for us by our friends at the Centre for Process Innovation, part of the High Value Manufacturing Catapult. That was a critical investment that industry had determined would be a sandpit really to help demonstrate new innovative platform technologies for new medicines, more sustainable ways of making existing medicines, and really starting to de-risk bringing those technologies through so that the pharma companies, who are by and large a very reticent bunch when it comes to taking innovation into manufacturing, it would give them the opportunity to de-risk, see those technologies in a live environment and think, yeah, we can do that too. We also invested in more capability in cell and gene therapies, a big growth area for the UK. And at the time we thought, this is great, this is going to be a really good foundation on which to grow medicines manufacturing in the UK. Little did we know how important those investments were going to be when sort of 2 years into that journey, the pandemic hit. And all of a sudden there was a real challenge and a massive opportunity to pivot some of those investments we made. We were still building MMIC, we were still building the expanded capability in cell and gene therapy catapult, we were still in the very early stages of VMing, but the investments we'd made were in people, and people with skills and expertise in manufacturing that enabled us to get the AstraZeneca vaccine turned around and manufactured at population scale really quickly. And I firmly believe without the investments we'd made through the challenge, we wouldn't have been in that position in terms of the expertise we had to drive that forward. not only had we invested in that infrastructure, but we'd invested in manufacturing capability within organisations as well, innovative manufacturing capability for viral vectors that was able to pivot at really short notice to actually scaling the manufacturing of that vaccine as well. And again, I think without that investment through the Challenge Fund, we would have not been in the position we were to get that vaccine out in the timescale we did. And you'll have seen around the room today some of the impacts that the challenges we've been celebrating here have had. Well, here's some of the impacts we had with the Medicines Manufacturing Challenge in terms of the number of jobs we created, the co-investment that we leveraged, but the number of new collaborations that we fostered through that challenge, I think, stood us in really good stead for what came next. So that really laid the foundations for transforming medicines manufacturing as a programme, and this was Innovate UK core funding with some additional funding from Office for Life Sciences and from BBSRC as well to take us up to the budget you see on the slide there. This was really about leveraging those investments we'd made through the Challenge Fund in the infrastructure and saying, now how can we start to identify real areas of medicines manufacturing growth opportunity in the UK and encourage companies to work with that infrastructure we've invested in to drive those innovations forward. So again, we made some small strategic investments, particularly with the Medicines Manufacturing Innovation Centre, and also introducing new capability with CPI and with other academic centres and the Medicines Discovery Catapult in intracellular drug delivery technologies, building on what we'd learned about lipid nanoparticles through the vaccines programme, and really trying to carve out a space for the UK in those technologies. But also nucleic acids, an important part of lots of development pipelines, lots of opportunity for more sustainable manufacturing platforms for these drugs, so we invested in those as well. Whilst looking to some of the technology we've seen around here today in terms of digitalisation, automation, net zero approaches to new materials, to try and bring those into the medicines manufacturing space as well. But also we invested in a community of practice to bring interested stakeholders from across the medicines manufacturing community together to help us shape the next programmes. This slide is just a small snapshot of some of the companies who have worked with us through the programme, working with the innovation infrastructure that I've talked about and collaborating with each other to bring some of these technologies to market. Yes, you'll notice AstraZeneca in there. But these are all small technology companies, new therapy developers, new manufacturing technology companies who are making a real impact now in the way that we manufacture medicines more innovatively here in the UK. And our success, I think, with these two programmes positioned us, I think, as the delivery partner of choice then for government when it came to look at a really innovative new public-private partnership, if you like, to deliver the Sustainable Medicines Manufacturing Innovation Programme. This is funded through the Voluntary Branded Medicines Pricing, Access and Growth Scheme, which is a mouthful in itself. You'll hear us talk a lot about SMIP because that shortens down the title on the slide. But this is the current programme that we're in the early stages of delivering now. We've just completed the first competitions and we're starting to fund a small programme of collaborative R&D activities and a bigger programme of manufacturing grand challenges. But you can see here some of the challenges that we're trying to address through this programme, which is we're delivering on behalf of Department for Health, but it's actually funded by industry rebates through this VPAG scheme. And it's all about how do we make better use of green chemistry? How do we make better use of the circular economy? How do we make better use of technologies that drive productivity and resource efficiency to position the UK as a leader in sustainable medicines manufacturing? We think there's a real opportunity here, and this is a first of its kind programme. I'd like to think that there might be opportunities to continue this type of model if we're really successful in what we deliver. But as I say, it's early days, but there's a number of things that we feel we can achieve through this type of programme that will really position the UK for success in this sustainable manufacturing field. So that gives you a flavour of the investments that Innovate UK has been making in medicines manufacturing, and hopefully what you've seen there is some of the touch points then between us as a very distinct community in the materials and manufacturing landscape. What I want to do now is get one of the companies who we've supported through this programme to come and talk to you about some of these experiences. So I'm really delighted to welcome Steve Wildman to the stage. Steve Wildman represents Sage Tech, one of the few beacons we have at the minute, I think, when it comes to circular economy in medicines manufacturing. So Steve's going to talk to you a little bit about Sage Tech and their journey. So thank you, Steve.
Thanks, Mark. That's the clicker.
That's the clicker.
Good afternoon. Thanks for the opportunity, Mark and Innovate. It's great to get another opportunity to talk about Sage Tech. Okay. So Sage Tech was born out of a recognition of a particular problem that is the result of the use of volatile anesthetics. That's the anesthetics that are used to if you go and have a surgical procedure, you'll often have a volatile anesthetic to put you to sleep. What we know is that around 95% of the drugs that are administered are released unchanged into the environment. That equates to around 4 million tonnes of carbon dioxide equivalents each year, and that is a result of these three drugs that you see on the right-hand side. Each of them has increasingly high carbon footprints associated with them. I will just point out that those values of carbon dioxide equivalents are for the emissions. That doesn't really account for the emissions associated with the manufacture of those drugs in the first place. It's a big problem. So Sage Tech sits at the heart, really, of a $7 billion industry, which is volatile anesthesia. And despite the bad press around volatile anesthesia because of the carbon footprint, it is a growing market globally. And what we can see on the left-hand side there, the breakdown in the UK, 65% is through the NHS, 23% is through the veterinary channel. The veterinary channel is a very significant user of volatile anesthetics. So this gave us an opportunity, partly because of the factors that I've talked about on the previous slide. 95% of the drug is wasted, essentially, and they're minimally metabolized. They're stable molecules, hence they do a bit of damage in the environment, and the environmental damage of the emissions and the impact of virgin manufacture of the material. So all these things together make a really excellent target for capture and reuse. So what we've developed is a circular economy solution that follows the drug from its administration at the top of the circle there to a patient. We then capture it. We then recover that from a filter material. It's then remanufactured or recycled and then certified for reuse. This is some graphics around our devices that we use. On the left is the device that's used in the veterinary sector, much simpler. It's got a single canister. It's got limited interaction. The device on the right is a bona fide medical device. It sits in an anaesthetic theatre, in an anaesthetic operating theatre, and connects directly between scavenging systems and an anaesthetic machine. It's fully interactive, provides a lot of information back to clinicians about what's going on with the device. So along Sage Tech's key milestone journey from our inception back in 2016 through to January 2025, where we are experiencing our first international sales of waste capture devices, we've been assisted by Innovate at particularly key stages. 2018 through the Challenge Fund that Mark was talking about, then in 2020 through a COVID continuity grant, in 2024 under the Flexible, Agile, Scalable and Sustainable Medicines Manufacturing Programme, and then most recently under the Scale Up Programme and the Sustainable Medicines Manufacturing Expression of Interest that we were recently successful for. And we can see The other key milestones are associated with technical developments, regulatory developments, and the grants that have facilitated that progress. Just a quick word about international. This is a really hot space for us at the moment, primarily because the regulatory environment, particularly in the European Union, is very favourable to the adoption of technologies like ours because of the impact on the environment. There's now mandated legislation for the capture of volatile anaesthetics. Hospitals will no longer be able to just continually just pump them off the roof. They will have to do something about it. It's a bit of a flag quiz here. So if I remember, it's Spain, Belgium, Netherlands, Switzerland, Austria and Poland we are very close or have signed distribution agreements with in the EU. Further afield, this is really driven by our interaction with multinationals. We've got interest from the USA and Canada, but also from Taiwan, Japan, and Hong Kong. So the opportunity is being recognised much more globally now. Just in summary there, the support we've had from Innovate UK, we really wouldn't be here without the support we've had from Innovate UK, so we're immensely grateful. Partly because of the funding we've received, but also there's a certain credibility that comes with a company that has attracted Innovate UK funding. And that has really impacted our ability to raise investment funds to complement the funds that have come direct from Innovate. I just want to say a few words about the Scale Up programme, which is the most recent support that we've been successful in. It's a fantastic programme. Anybody who wants help at board level or below, this is a really good opportunity. They will come in and assess your business with you and identify key areas where they can add value. They say it's like having 40 or 50 additional non-executive directors on your board, and it really does feel like that. For us, the 4 areas are finance, IP strategy, sales and marketing, and organisational development. And we get a dedicated scale-up director, action plans developed, and we get the expertise and connections that those individuals bring to the project. In final, really, I think what we've been able to do with the help of Innovate is really become a global leader in waste anaesthetic gas capture technology, and we are absolutely at the forefront of clinical understanding. We have really maintained our allegiance to our core values of quality, safety, sustainability, and efficiency, and I think that's what's stood us in really good stead, and I hope will drive us into the next successful phase with more commercial adoption. And I think that's me. Thank you. Was I on time?
Brilliant.
Did I?
Spot on. Yeah.
Oh.
Do you want to take a seat over
Yes.
there, Steve? And as I said earlier on, I guess I should qualify the statement I made earlier. I am a Yorkshireman by birth. You might not tell from my accent, but as I touched on, I think it's really great through things like the Challenge Fund that Innovate UK has been able to support some earlier TRL activities. From the position of Deputy Director of Medicines Manufacturing, it's even better when I'm not spending my budget but somebody else's. So with thanks to our colleagues in the Made Smarter Innovation team, I'm really pleased to welcome Alistair Florence to the stage. Alistair is Professor of Pharmaceutics and Director of the what was the Centre for Continuous Manufacturing and Crystallisation, but now much better known as CMAC, I think, within our community. And Alice is going to talk to us about some of the Made Smarter innovation funding they receive for digital medicines manufacturing.
Thanks very much, Mark. So as Mark said, this is really giving an overview of some of the activities that we've been delivering through the Made Smarter DM Squared, the Digital Medicines Manufacturing Centre. It's been running for the last 3.5 years. Along the top, this is our sort of image, our vision for Lab of the Future. How do we use industrial digital technologies to make us more productive, our researchers and operators more insightful, creative, wiser, and altogether more fabulous and wonderful? That's the intent. Medicines, incredibly competitive environment. Development processes can be quite long, often lead to suboptimal processes, the pressure to get into the clinic fast and fail fast with new medicines. Our interest is beyond drug discovery. And I think one of the interesting things is evidence that AI is increasing the number of drugs being discovered, and they are functional materials. And those drugs are also more effective, so more of those new medicines being better, more effective medicines. So that puts increasing pressure on our ability to develop the products and processes to get them to patients. So that pressure on the chemistry manufacturing control, or CMC piece, as well as costs and so on. So really the motivation here is to bring together advanced manufacturing technology, industrial digital technologies, to actually deliver the kind of benefits, reducing cost, the inevitable drive around sustainability. How can we use these technologies to optimize our processes, not just for quality, but also for minimizing environmental impact? So this was sort of broad framework we laid out in our proposal to establish DM Squared as part of the CMAC portfolio. 5 key platforms: a data platform, a manufacturing platform, digital quality control and how we can build systems to allow us to build confidence in our models, and also think about supply chain, how we can better meet the needs of more agile supply signals, and think of clinical trials. And then the people element, building out the skills and the platforms to actually ensure that we have the knowledge base across the workforce to implement this. So there's a range of different industrial digital technologies. Again, the Made Smarter Innovation Call, the research centre is very much rooted in the Made Smarter report and how we can bring these different types of capabilities and build integrated solutions that deliver the higher level ambitions of the programme. So data platform, very much, how can we bring together some of the, pharma can be very siloed in terms of different operations, different steps from your raw materials, through individual processes, the decision making, legacy systems. People talk a lot about digital transformation, a lot of effort, how we can extract data from legacy systems. I think we've been able to start almost with a clean slate and build out the platform, as I say, more for that lab of the future. So just looking, in terms of some of the elements that we've been able to build out, fundamentally identifying all of our data sources and how we can connect to all of the instruments and equipment that we're using to generate the data describing our materials and processes. Building out that data schema, the framework, so that we can identify all the data and metadata describing those data at all of the stages in our process. Building out the platforms and interfaces. Again, one of the great things DM Squared allowed us to do is bring in those skill sets into the team. So very multidisciplinary, not just process engineers, pharmaceutical scientists, analytical science, but also data engineers, data scientists, software engineers, part of the team enabling digital transformation. But how do we make the data accessible? That is often, I think, many projects we've been involved with through Advanced Manufacturing Supply Chain Initiative, for those that remember AMSCI, Adopt, Remedies. A lot of effort just getting data from companies. So again, building out those future systems. In terms of enabling semantic tools, ease of access to data from these complex networks that are involved in medicines development. Implementing knowledge graph capabilities, so building out the ontologies as well and really trying to transform our data infrastructure. Lots of efforts as well, making these complex data systems accessible, interpretable by our users, so building out the interfaces as well. We've got a couple of examples I'll maybe highlight from the other platforms. But I think really looking how can we bring natural language interfaces and the really benefit from the progress in artificial intelligence, natural language programming and so on into the pharmaceutical domain, and starting to build out some of those demonstrators as part of the programme. So that's platform 1, build out the data. That's essential component. It informs our decisions, the design of our products, the design of our processes. Platform 2 is our microscale direct compression manufacturing platform. So we're focused on tablet manufacture. And the goal in really condensing down the time from presented with a new active ingredient to delivering a formulation that meets the performance objectives required for immediate release oral solid dosage form. So we can now produce a new tablet formulation that meets those requirements in 6 hours. So this is typically, you would be weeks in terms of formulation development and testing. We're reducing the amount of material as well, so starting to play into the sustainability agenda, and again, freeing up our human resources. So there's a number of elements. The digital formulator, so actually this system of models that describes the material properties, the process parameters, and how those relate to the performance objectives that we're trying to optimise. The physical infrastructure in terms of what we term a data factory, so if you're familiar with self-driving labs and some of these areas, how do we bring that into direct compression space? And then also the human-machine interfaces, and we've been focusing on augmented reality as one of the platforms. So a little video here just sort of showing the platform, so some the interface. You can set up a sequence of experiments just to automate, but the goal here is to set the performance objective and use the smart algorithms, Bayesian optimization and other multi-objective optimization approaches to allow the system to navigate the best sequence of experiments through the design space to meet your objective. So we can dose our powder, we can inspect the powder to make sure we've got the right mass, we've also got the right composition. It's then going into a compaction simulator that mimics a commercial tablet press. We can then explore the different process conditions, and we can then submit the tablets for testing, whether we submit them to stability testing or immediate destructive testing, looking at the mechanical properties, the dimensions of it, to make sure that we're within the required ranges. And again, this from a technology point of view starts to bring in, we've got multiple tasks, parallel workflows now, so the scheduling and automation of that, again, just enabled by the team. Here we're bringing in proxy tests, so thinking really what we want is that immediate release performance, and this is a separate station where we're looking at sessile drops, so this is a proxy for dissolution. We're looking at the wetting and the swelling of the tablet as one of the indicators of the formulation performance. So all of those steps now automated, and this is really the goal. It's that productivity in terms of access to data, both the journey to the performance of the optimal formulation, but also now the ecosystem that we've got, the legacy data. We learn more as we take on more systems, more excipients, more active ingredients, more formulation performance objectives. We actually have this rich data asset upon which we can start to build new data products and models. The platform can also be deployed then once we do the development, exploring the design space, we've identified the optimal conditions, we can then actually produce small batches of tablets as well. Around about 1,000 tablets a day, which starts to meet the requirements of your initial clinical trials needs. And so opening up that responsive supply chain, manufacture to demand, not to stock, and some of the benefits that brings. And just the technology, not just, technological party tricks, but actually the potential to open up new and improved business models as well, with direct benefits to patients. On the extended reality piece, again, we've been working with colleagues at Glasgow School of Art, their simulation visualization department, just to bring in the real-time data. So we've been using HoloLens, but looking at a range of technologies for how do we bring data from these complex systems at key steps to the operator to inform their decisions. So again, we've got some real-time data flows, also bringing some of the training assets here. But again, that work's continuing through our new programs, just looking at how we get the input from the operators to really target that to deliver benefit. I'll not go through all of these videos in the interest of time. Models at the heart of predictive design. One of our colleagues at Loughborough University, so Brahim Banyahi and his team, built out the ESTAN toolbox. This is looking at global sensitivity analysis and estimability analysis. So given a particular model to predict some outcome, how good is my model? And how reliable is it based on the data that I can access, given the crucial nature of these models in terms of this model-based design of experiments and self-driving labs approach? So they've built a tool where it allows us with some limited experimental data to get the sensitivity analysis, what are the most important features in terms of predicting my outcome, but also given the quality of my data inputs and the information content, what's estimability? So allowing you to focus on making sure your model is appropriate and you're making appropriate reliance on those predictions, but if you also need to focus on improving your measurements or altering the model to make sure you have that credibility in terms of the reliance on the prediction. Platform 5, again, just bringing all of the knowledge, the tools, the training materials as well together, so just building out a platform or a skills factory so that currently our internal users can access this, but we're rolling that out in our new Centre for Doctoral Training in Cyber Physical Systems as well, so just building that legacy from the DM Squared platform. So in almost exactly on time, and a shameless piece of self-promotion, if you want to find out more about our new programmes, how we're building on this and extending this beyond tableting to the other key stages in product and process development medicines manufacture, please do come to visit our open days. We've got a showcase from DM Squared, the second generation technology demonstrators. And you can meet the team, see the case studies, and interact with the technologies as well. You will, of course, those of you calendar aficionados will, of course, know to come to the University of Strathclyde and visit us on the 16th would be a stupid idea because that's a Sunday. We'll be closed, we won't be there. So the natural intelligence, I'm afraid, has let me down. I got the dates wrong. It's the 18th to 20th. I should have used my own ESTAN toolbox, perhaps, on my PowerPoint slides. But with that, love to see you. Happy to answer any questions, but I'll stop there.
So with that, I would like to invite Janet Geddes to join us on the stage for the panel. Janet is our Deputy Director Global, and thank you again for extending your stay here today to be with us. Some of you may have been in Janet's session this morning where she talked about some of the global programs, but of course medicines manufacturing is very much a global value chain, and there is very much an opportunity for us to position UK companies as being, as I said earlier, sort of leading in some of the technology. So it's with that in mind that I want to come to Janet first as we open the panel. We're already working closely with Janet's team on delivering a bilateral program with Canada around biomanufacturing, which was kind of spawn out of the pandemic and looking at how the UK can work with Canada, who's a very like-minded country in terms of innovation, to work together to kind of grow our own resilience within our supply chains when it comes to the medicines and we'll need for the next pandemic. So with that in mind, Janet, I was wondering if you could maybe sort of remind us again about some of the things you covered this morning. What are some of the tools, products, services we have within the global team that can help companies maybe such as Steve? We've heard a little bit about Sage Tech's international journey. Some of the things that we as Innovate can do to support companies who are also on that journey when it comes to interacting globally.
Sure. Hi, everybody. Quick disclaimer, it's towards the end of the day, so if I don't make any sense, apologies for that. But yeah, firstly, thanks, Mark, and I think just to raise awareness that Innovate UK does have a global programme. We are trying to support UK SMEs and large businesses to engage internationally. Our support goes beyond export support, so we don't see ourselves as providing directly that sort of support. We see ourselves enabling UK businesses to connect to potentially to R&D partners in other countries, if they want to find a manufacturing partner in another country, a knowledge partner. They might be on an export pathway but are not exactly there yet and need to understand what it takes to enter a new market abroad before they actually go ahead and do that. So we've developed a toolkit, I guess, along those lines, and we've got two main streams of programming. So firstly is to help you as a UK business to undertake R&D with businesses and research organisations in other countries. So hopefully you're all aware of the Horizon Europe opportunity. It's a complex beast, but we've got lots of support there to help you navigate that. So we've got people who can talk you through what it takes to apply in and what you need to do. There's lots of online resources as well, so please do have a look at that. And then we've got other multilateral programs, primarily with European countries. We also run bilateral R&D programs with about 10 other countries around the world. Mark spoke about Canada, and I'm sure can elaborate a bit more about what that's involving. And we also have other sector-specific programs as well. But quite often our bilateral programs are open in scope and therefore are applicable to hopefully businesses within the sector. The other main stream of work is for businesses, particularly SMEs, who are looking to enter new markets or explore partnership with a new market. So we've got two different programs that enable a UK SME to spend time in the market. And we're finding out of those time in market, businesses are, even if it's a week long, they are forming partnerships. We're seeing actually investment come out of those, licensing agreements, etc. So they are delivering fruit. We have also, but we curate those opportunities. So we'll say, okay, we think there's a good opportunity in advanced manufacturing with Singapore, for example. We also have a longer incubator program that enables you to spend more time in market, and that's led by an incubator from that country. So they know their markets well, they have the connections in country. We also have a program that is called Global Explorers, which is enabling, it's a small grant fund to help you work with a business, with a market of your choice, rather than us suggesting where the opportunity might be. So we have quite a toolkit. I'm happy to speak to anybody about it. All the information is there online, and yes, please do think about it if you're looking to engage internationally.
Brilliant, thanks Janet. Conscious of the time, I do have a couple of questions that I can throw at the panellists, but if anybody from the audience would like to ask a question on anything they've heard this afternoon, I'm going to open up to you guys for an opportunity first. We have one at the back there, lovely.
Thanks for all the speakers. Just on the last point, Janet, so I'm a super early stage startup medical device. At what point is it appropriate to engage with yourselves about trying to understand external markets?
It's a good question. I think there's no harm, and to your benefit, probably to speak to us or to our business growth team. So depending on where you're based, we can connect you up to the right business growth team, Innovate UK business growth team, and they can have a conversation with you because they deliver the second stream of work that I spoke about. It's done through that team. It really depends. So we do look at applications that come in and really judge whether this is an appropriate program for businesses. We obviously have a conversation as well. So if we deem it's too early, we will give that feedback. But I think having a conversation, we know many businesses are born global in this sector. There's huge opportunities internationally, so it's very context specific, business specific. There's a non-answer if you've ever heard one. So.
I could add something to that. from SageTech's experience, I think because of the financial landscape, particularly in the NHS, for adoption of innovation, particularly around sustainability, we were really kind of almost forced to pivot and look internationally, probably before we had anticipated we would. So I think in terms of assessing your market, I would get on with that. I think it's, I think exploring that opportunity, I think has been a really successful strategy for us.
Any other questions from the audience for our panelists?
Thanks for the talks there. I have a question about the medicines manufacturing portion. So, as you know, it's a global industry, like you mentioned. Is there any effort being made towards increasing manufacturing locally? Because I know lots of companies will do R&D here and then outsource all their manufacturing. So, if we're going to be developing manufacturing technologies, are we also going to look at onshoring manufacturing back to the UK?
Yes, that sounds like one that I probably need to field first. So yeah, absolutely. And I think it's fair to say that the interventions that I've talked about, from the Medicines Manufacturing Challenge Fund through to the Sustainable Medicines Manufacturing Innovation Programme, one of the things at the heart of those programmes has been to develop technologies for manufacturing here that we can exploit within the UK manufacturing base. So whether that's within the big pharma companies that we do still have here, AstraZeneca, GSK, whether it's within the breadth of the contract development and manufacturing organisations that we have across the UK who are supplying into those bigger pharmaceutical companies, one of the things that we want to drive is the uptake of those technologies we're developing here in the UK by those companies in the UK. Of course, we recognise that there's an opportunity for the UK companies developing these technologies to license them globally, and that's great too. But yeah, if we can use that to grow the manufacturing capability here in the UK, that really is a win-win for us. Alistair, I don't know whether you want to sort of comment on that as well from a sort of broader CMAC perspective, perhaps, in terms of the work research you're doing and how that might kind of feed into UK PLC.
I think it's a question we get asked a lot. We spend millions of pounds on research training, and where's the bit impact going to be? But it's obviously a complex system, and you need, I think the government policy, what are the incentives, the regulatory alignment as well. I think the pandemic created a lot of interesting conversations. The US took a national security approach. We nearly ran out of paracetamol in the UK, one of the most basic medicines around, but the shortages in intensive care medicines and so on. So I think that's brought the spotlight onto, from existing essential medicines, what's the security of supply in terms of global supply chain. We heard in the session earlier, though, there is no such thing as a sovereign supply chain. It's impossible. Is that the case? I think with new modalities as well, manufacture closer to the patient. I think things are changing. The example that I presented, I think part of this is how I think the large multinational pharmaceutical companies are a hugely important part of our economy, the global economy and societal health, but it's also enabling small companies to access manufacturing technology at much lower cost, and enabling them to do more that I think can also be part of the answer to keeping the technologies in the UK, because we're seeing the benefit and anchoring the impacts from the research in the UK. But it does need a multi-system approach. I mean, everything needs a systems level approach. I don't know why we don't bother starting at that point all the time, because it always needs that joined up thinking. And presumably the UK's got the potential to join up those elements and start to deliver some real impact, and the benefits from Catapult, MMIC, CPI, research centres like our own, SMEs, and how do we create that kind of cluster type model that Boston and other places around the world, Singapore, are really leaning into. So I think we need a long-term strategy. Again, we heard about industry strategy earlier. We need the regulatory. I know the new CERSI call that's been supported by Innovate MRC and so on recently. We're starting in the UK to catch up with where the FDA have been for maybe the last 5 years. And global leadership and regulations, another way I think we can capture leadership and opportunity nationally. So I think there's a lot of those things happening. but we need to stay the course, and we need to really drive it through to succession. But that's the humble academic's view.
I think that brings us really nicely to time. So with that, if you'd like to join me in thanking our speakers this afternoon and our panellists. Thank you all for joining us as well. I hope that's been interesting for you all, and safe journeys home, everyone. Thank you very much. Thanks, Alistair.